hello everyone. I'm glad to see you all today here on a venue in Moscow and online. You have done a great work for the last 6 months and achieved the great results. And we would like to see your presentations today and check all your articles and what you have done, check your projects and assess it and define the winner of our competition. So I'm very happy to be here, and I very want to see what's going to be next. And I want to say thank you for all organizers and jury who also present here. And please, everyone from the jury, let's introduce yourself and say a couple words to participants. Now, Alexander, maybe you next.
Hello.
Yeah, we can hear.
Hello, my name is Alexander Fomenko, and I work as a UIS lab coordinator and professor at Middle Tennessee State University, United States. And it's a big honor for me to be a member of jury here, and I've been really fascinated watching your team's progress and actually finally reviewing the final reports and articles. And I'm not a real expert in the coding of aerial robotics. However, the level of work that has been done is enormous, in my opinion, and I'm looking forward talking about the commercial applications that I very much see a lot of opportunity for. Let me pass the word to the next jury member, and I'm more than excited to start watching the presentations. Thank you.
Thank you, Alexander. Alexei, could you be the next?
Okay, yeah. Hello, everyone. Nice to meet you. And my name is Alexei. I worked at COEX and one of the author of platform Clover. I very excited about to be a member of jury in this competition, and I want to wish all of participants good luck, and let's start. And who will be the next jury member?
Yeah, hello. I'm Andrei Turegotsky, Copter Express CTO. I'm still on my way to the event. So yes, the articles are great, and I wish good luck to all the participants. Eager to see the presentations. I will be there soon.
Thank you, Andrei. We are waiting you soon on the venue. Oleg Kovachev, could you say something from your side?
Yeah, hello everyone. I'm the lead developer of Copter Express, Oleg. So I'm really glad that we continue our tradition to hold CopterHack event, which we began in 2017. So it's 5 or 6 years of this event, and we always wanted to get a lot of people into flying robotics, and I think that we have done this a lot. I want to say that the level of projects in this event raises every year, and I see it because this year, as I read articles, the level was really high, and I want to wish all the teams good luck, and so good luck to everyone. Thank you.
Thank you, Oleg. So who is next? Ilya, Yulia?
Yeah, so I'm a world break skills expert, maybe, also from COEX company. I'm really glad to see everyone here. Guys, actually, you did a great job this year. It has been a really tough contest, and the finals will be very interesting. I've read all the projects you've done, and they're really thorough made. So that's really cool. I'm excited to see everyone here, and let's see who'll be the winner, and also review the other projects. Thanks a lot.
Thank you, Ilya. Yulia, Tatiana, hello. Nice to see you here. Yulia, could you say something?
Hello to everyone. My name is Yulia, and I'm organizer of different competition in flying robotics in Russia. So I saw your projects yesterday and before. So it looks very interesting, and I'd like to hear it in our final of hackathon. So I wish good luck to everybody, and interesting who will be winner of this competition.
Thank you, Yulia. So I think we have done with the jury presentation and the jury introduction awards, and so we're ready to start to see the presentation of teams. Right, Yelena? Please go ahead.
Let's start our team presentations. We wish you the best of luck. Please welcome our first team, T305. I'm waiting. Great. Let's fly them.
Jack, I'm sorry. Jack, are you here? Before the first team will start, please say a couple of words from yourself.
Yeah, sure.
Please.
Everyone,
Sorry.
it's good to see you guys again. I just want to congratulate all the participants on doing some really good work. Like it's very impressive. I joined a bit late, but I went through everything, and it's really impressive work. So congrats, and I'm looking forward to seeing what you guys are going to present. And good luck to you all.
Thank you, and we're very happy having you here today. Thank you for staying with us. Okay, we're ready to see the first presentation, the team C305. Please, the stage is yours.
Hi everyone, we're a team of the students representing the Center for Design Activities of the Far East Federal University. Our team consists of students studying different courses and specialties. Ruslan, head of this project, isn't with us together. CR guy Filimonov, the main software engineer of our team. Nikita Smadic, software engineer. And George Antonov, the engineer of this team.
В настоящее время все больше предприятий допускают выброс опасных вредных газов в атмосферу нашей Земли. Вследствие чего проблема загрязнения воздуха становится наиболее актуальной, а также поиск очагов загрязненности воздуха.
At present, with the growth of emissions of harmful substances into the atmosphere by various enterprises, as well as the increasing cases of man-made accidents and disasters, the problem of finding hotbeds of possible air pollution becomes relevant.
Поэтому надо было придумать такое решение. Создание программно-аппаратного комплекса для стандартного набора Clover, которое позволит нам в автономном режиме проводить анализ загрязненности воздуха на определенных площадях.
Therefore, as a competition project, we chose an automatic air monitoring system, which greatly simplifies this process and also allows it to to places inaccessible to humans, for example, at a height of 100 meters.
Это имеет ряд определенных преимуществ перед классическим анализом воздуха. Некоторые из них – это уменьшенное количество людей, которые необходимы для достаточно всего одного теории, который запустит программу.
The tasks that we set to ourselves were to develop an automated system for measuring the content of industrial gases in the ambient air, which is convenient for the operator. Our innovations will make it possible to use the copter to search for areas with a high content of gaseous substances, potentially hazardous to humans and the environment, to build an air pollution map and mark zones with critical gas concentrations on it.
Также это позволяет проводить замеры в недоступных классическим образом местах, в каких-то опасных зонах или на больших высотах.
Also, it will allow us to perform measurements on different inaccessible to human positions like heights or some remote areas.
Нами были поставлены следующие задачи. Первое. Разработка платных газоанализаторов, которая позволит нам собирать информацию о загрязненности воздуха.
So we set the following tasks to ourselves. First, to collect information to develop the gas analyzing system.
Разработка системы облета препятствий для стабильной навигации вне помещений и в помещениях.
The second one, to develop a navigation system in enclosed environments.
Разработка приложения наземной станции, которая позволит задавать маршрут и определенные характеристики маршрута.
To develop the ground station, which will be able to provide us the routes for navigating.
И в конце испытания всей нашей проделанной работы.
And finally, testing our working prototype.
Начнем с платы газоанализатора. Она состоит из нескольких датчиков, которые позволяют нам определять влажность, температуру, а также различные газы. И базируется на схеме S305. Для теста была взята отладочная плата S305.
So the first slide is dedicated to gas analyzer board. To obtain information about the composition of the air, a gas analyzer board was developed and later installed on the drone. It was developed on the STM32 platform, a microcontroller, and we also used the Arduino Nano board.
Также была разработана собственная плата, разведенная для дальнейшего масштабирования проекта.
Then later we developed our own PCB board for later usage of this project.
Система облета препятствий состоит из установленного на дрон лидара, модели A1 и метода потенциальных полей для облета препятствий. Лидар позволяет нам обнаруживать все препятствия в плоскости полета дрона.
Obstacle avoidance system for our project consists of RP LiDAR A1 and the navigation system using the method of potential builds to fly around obstacles encountered by the drone on its path.
Также было разработано приложение наземной станции, в котором мы можем задать необходимую площадь для облета, он автоматически простроит маршрут.
Later we developed a graphic user interface. This interface consists of several windows. The main window allows the station operator to start and stop the drone's motors and execute the mission.
Также можно задать определенные параметры высоту полета, точность позиционирования и получать обратные данные с квадрокоптера, его текущем положении, угле поворота и заряде батареи.
You can also adjust the flight parameters and also review the telemetry data.
Следующий слайд, пожалуйста. Спасибо. Также было разработано приложение визуализатор, которое позволяет нам совместить данные, полученные в конце миссии с газоанализатора, с самим маршрутом нашего полета. И таким образом наложить визуально, где предыдущая норма допустимых газов, температур, каждый показатель можно сказать в отдельности, где он находится в норме.
Additionally, we developed the visualizer app, which allows you to link the flight route with the pollution map and track it based on the GPS. This interface allows you to select the required gas and use concentration in the particular area. Then we carried out several tests, which you can see in the presentation. The tests are actually in GIF format, but it's not working currently. But I think we may probably ask the guys to send these GIFs to the chat later.
На первом изображении вы можете видеть тестирование полетов на улице с удержанием высоты и проведением миссии.
So the flight test was performed and the drone showed well.
А на втором вы могли увидеть тестирование облета препятствий и помещений. Подскажу, что там происходит. Там установлен перед квадрокоптером тонкая алюминиевая балка, примерно 20 см в ширину. Квадрокоптеру поставлена цель облететь эту балку, залететь за нее. И он способен автоматически облететь и вернуться на маршрут.
And on the second GIF, the guys showed the test for obstacle navigation. The objective was to fly over the thin metal rod, and the drone performed. One was proletail, one was and the drone performed correctly. So the obstacle avoidance system worked.
Для результата мы можем сказать, что в ходе всех наших испытаний мы можем сказать, что наша работа выполнена успешно. Нам удалось провести все необходимые тесты. У нас получилось собрать данные на нашем кампусе Дальневосточного федерального университета, и дрон показал крайнюю стабильность в ходе своей работы.
So based on the results of the test performed, the guys, this team is very proud to say that the drone worked well. It's actually fulfilled all the objectives, and they're really satisfied with the results.
Мы считаем, что мы справились успешно, надеемся, что нашу работу оценят, а также надеемся, что в дальнейшем оно послужит на пользу человечеству и, возможно, станет основой для других инновационных проектов.
So the team really hopes that such solution will win the competition and later will serve the humanity and also bring them the first prize. That's it for the first team.
Thank you very much.
So any questions for this team?
Yes. Thank you very much for the presentation and for work you have done. Wonderful work. A lot of things you have done. Really, we have checked your article and documentation. So I have a question about your PCB board. Have you already assembled the first prototype of this board or not yet? Hello, do you hear me?
Да, слышно вас. Еще раз, можно, пожалуйста, перевести вопрос? Я просто...
Have you already assembled the first prototype of your PCB board, or you have just developed it but not assembled yet?
Да, мы только разработали сам дизайн, но мы не собирали прототип, поскольку те датчики, которые были на плате, они были достаточно дорогие, и была вероятность, что при пайке они могут повредиться. Мы такого себе не могли позволить, и мы были ограничены по времени.
Okay, it's okay. Thank you.
Да, выше. Вот о чем говорит Руслан, что в ходе наших тестов мы использовали пакетную плату с окладочной платой SNAPE-32, но для дальнейшего масштабирования данного проекта мы разработали отдельно разведенную плату, которая может подключать напрямую.
So during the tests, guys used
Вопросы можно, да?
later, they have developed their own.
Мы ее только смоделировали, мы ее не раскопали.
So for this project, tests, the prototyping board was used, and tests for their own development. It was developed, but it's not produced yet. Any other questions?
Да, на каком языке задавать? Алло.
Ну, можешь на любом языке.
В общем, я не очень понял, то есть было ли испытание, может, я просмотрел на улице, потому что я так понимаю, что это имеется в виду, что он будет какие-то большие территории исследовать. То есть было ли испытание на улице на большой территории?
На улице на большой территории. Да, мы проводили испытания на кампусе Дальневосточного федерального университета. Как раз таки это было представлено на предпоследнем слайде. К сожалению, GIF изображение не погрузилось, но вообще, да, они проводились по большей части у нас на улице.
Okay, so...
А можно посмотреть, извините, может быть, не все просто понял, а можно посмотреть картинку, которая была получена с уличного испытания? Или это она и есть, вот непосредственно реальная?
Картинка, да. Верните на визуализатор. Выше. Ну, в смысле, вон, 8-й слайд. Или какой, да, 8-й. По поводу визуализатора. На данном слайде мы хотели показать именно функционал данной программы. К сожалению, мы не успели пролететь всю эту площадь и проанализировать. У нас есть данные полученные, но они сильно меньше площади. Это сгенерированные данные просто для отображения функционала.
So on the visualization app slide, you can see the map with some results, but that's actually a visualization. I'd say that they have tests outside, but on a relatively small time. Any other questions?
Yeah,
Yes.
sorry. Can I ask a question?
Yeah,
sorry.
sure.
I wanted to ask about how you're connecting or how you're communicating between the drone and the base station. I see in the diagram in your documentation, you mentioned Wi-Fi. Maybe I'm just missing something because the diagram is in Russian and I couldn't translate it. Are you using a VPN connection or does it have to be like a local connection to the Wi-Fi hotspot on the Raspberry Pi?
На данный момент происходит Wi-Fi, в принципе, это решается легко, ставится либо модем, либо любой датчик внутри, частота, и в принципе это решается очень легко. Но на данный момент, да, тестируем, у нас лично Wi-Fi сейчас.
So Jacques, answering your question. Answering Jacques' question, the guys confirmed that they have been using Wi-Fi, but they told us that there are plenty of solutions to organize the telemetry above the Wi-Fi channel.
Thanks.
How do you see your further development of your project, and whom would you work for as a start? Just maybe free or almost for free for your portfolio?
Мы хотим добиться чего? На данный момент дрон способен стабильно летать по улице, с удержанием позиции, маршрута из всего, и облета препятствий. Мы хотим модернизировать его, чтобы он был способен полностью автономно также полетать внутри помещения. Потому что на данный момент он внутри помещения только способен облетать препятствия, но он не способен до конца строить карту. В принципе, это вполне реально. Мы собираемся сделать эту модернизацию, во-первых. В плане задач он тоже учился.
Okay, Alexander, so answering two questions. First, team thinks that as the first step, they would like to upgrade their drone flying capabilities indoors, because currently the drone is able to detect and fly over the obstacles, but it's not able to route its indoor navigation. So the second part of the project would be actually developing indoor navigation localization. And as for the potential customers, they aim at Ministry for Ministry for Emergency Situations. Yeah, sorry.
All right. So as a follow-up question to that, did you conduct any marketing research and find out who would benefit from using your system and who would potentially contract with you? Or because as for me, this looks as a great system has been developed and has a lot of potential. However, is it impossible? Was it possible to find anyone who would be interested in buying this product when it is completed, or at least allowing you to test it at their facility, so you could pick some real-world cases for your team?
Маркетинг проводили мероприятия, мы имели практику разработки самой системы, не продажи этой системы. Поэтому МЧС это лишь наша гипотеза, кому это реально может пригодиться. Ну и у нас очень интересно. Спасибо.
Answering Alexander's question, the team says that they have those thoughts that Ministry for Emergency Situations could be their customer, but they haven't performed any marketing research yet. And thanks for valuing their project.
All right, thank you.
And I have the last question. I think it's did you try make your indoor navigation in narrow places like pipes or somewhere else?
Как я переведу, если somewhere else? Леша, could you possibly just
Окей, давай по-русски скажу. Ребят, вы пробовали вашу систему, основанную на лидаре, в каких-то очень узких местах? Ну, то есть в трубах или в чем-то подобном?
У нас есть одно испытание проведенное, оно не совсем, конечно, в узких коридорах, но мы пробовали прогонять его сквозь восьмерку. То есть дрон летел ниже этой восьмерки, прям в середину, и в ходе полета он смог перестроиться и полететь внутрь восьмерки. У нас такой тест был. А конкретно в узких помещениях у нас не проводилось тестом.
Гипотетически он может в узких помещениях.
Ну да, гипотетически метод специальных полей позволяет это сделать.
А там только настройка параметров.
Ну, просто интересно, вот насколько у него точность определения, вот насколько его полет влияет от расстояния до препятствия. То есть...
Все зависит от точечной настройки. Так как у нас по факту есть некоторая зона, внутри которой идет детектирование объекта, методом центра складываем драйв, получаем сутирующую силу. тем самым, чтобы облететь эту
Ну, то есть у самого лидара точность достаточно высокая.
Мы исходили из того, что это самый доступный лидар внутрь из готового решения, которое можно использовать. Во-первых, в любом случае мы же open source делаем, то есть, чтобы после нас могли легко доработать и интегрировать наши решения.
Спасибо большое, все понятно.
Была в смысле фигура классическая из построенной из труб. Цифра 8 большая, построенная из труб. Дрон летел к середине для досмотра, в перекладине, правильно? Вот. И в ходе полета он просто задетектировал препятствие перед собой, и он перестроился не по своей плоскости, а по высоте на это препятствие. И пролетел внутрь в смысле рассмотки. Есть.
Можно?
Да, но он видит, да. Ну, пока оно будет здорово.
So, just translating this discussion shortly, they have performed tests for flying in some detained space, but they've been using the key objective of this project was using the open source and most affordable LiDAR. So these tests could be continued, but at the moment they have proven that the onboard LiDAR works pretty well.
Okay, thank you very much. Thank you for your wonderful work. Great project.
LiDAR weighs about 300 grams.
У нас репозиторий, кадовские файлы платы репозитории, также там есть кадовские файлы защиты лидара. А есть файлы? Да, должны быть у вас. В любом случае, надо обратиться к моменту голосования, можно часто просить, а можно через скидку. Хорошо.
Thank you very much. Our next team is FTL. FTL, are you ready?
Hi, can you hear me?
Yes. We can hear
Okay,
you.
cool. I will share screen. Oh, how much windows? Can you see my screen?
Yeah, right.
Okay, cool. Hi, I'm Maxim Romanovsky from Team FTL, and I'm presenting our project Clover Sim. Clover Sim is a project aimed at making advanced simulations easy. We are FTL Team from Minsk, its capital of Belarus. Our team has won many different contests, such as CopterHack 2021, Artificial Intelligence International Junior Contest 2021, Autonomous Transport Systems Profile of NTO 2022. On the left side, you can see me. I have done all research, design, and development of Clover Sim. My teammate is Mikhail Kulik, who has done documentation and testing of Clover Sim. Clover Sim is designed to be used in different areas like virtual competitions with automatic assignment checking, continuous integration and testing for different projects, and online courses with not only theoretical part, but the practical part too. Before our project was created, there were two ways of Clover simulation. First one is manual setup of Gazebo, Rost, and Clover. This method provides great performance and good DOS integration, like alt-tabbing into Gazebo and use of preferred IDE. On the other side of hand, it's pretty hard to set up, and there is almost no task support. Another way is simulation virtual machine. It's easy to set up and has simple task support, but this comes at cost of lower performance and poor OS integration. And Clover Sim combines advantages of both methods. It's very easy to set up, has powerful task support, provides high performance and good integration. And that's not all. One of main concepts of Clover Sim is workspaces. If you're working with Clover simulation using VM, it's kind of hard to work with multiple projects simultaneously because of conflicting configs or packages, and this is where workspaces help. Workspaces store all your code, configs, and packages so you can easily switch between different projects, but just switching between different workspaces. You can even export them and send to your friends, or to backup your current state of things. You can see other workspaces features and their usage on slide. Another cool Clover Sim feature is tasks. Tasks are used for testing your program in different environments. And when I say different, I mean different. You can have a limited number of random world-generated tasks. If you want to return to previous randomization, you can do it. Each world is represented with seed, which is basically a simple, rememberable string. For example, you can try a randomization sent by a friend, or have a list of randomizations to test your program in most important conditions. On slide, you can see example of one randomization, and another one, and another. Also, tasks can be automatically checked by checking system. The system is able to get Clover position, emulate hardware like grippers, and check monitoring reports created by user programs. On slide, you can see some examples how scores could look like. And that's not all Clover Sim features. Clover Sim can be used on Windows via VSL2 support. Performance of Clover Sim is higher compared to virtual machine. Because of containerized system, user code doesn't see any gazebo services and topics, which leads to closer to Clover environment and isolation of user code, so it wouldn't be able to modify gazebo world. We plan to implement new features. One of the most important one is ARM support. This will allow Clover Sim to work on Raspberry Pi and Apple M1. Also, we think it's a great idea to add support of full Raspberry Pi virtualization via QEMU. This will make testing environment even closer to real one. And another planned feature is multi-copter simulations. Well, that's all our product presentations. Thanks for attention. Now I can demonstrate our project itself or dive into some technical details. Desktop 1. Boom. Here, a second. Right. Here you can see schematics of how Clover Sim works. There is Clover Sim tool. This tool controls and launches containers. It also has virtual test server, which allows containers access to OpenGL, so gazebo will get accelerated GPU rendering. We have two containers. In current design, we have two containers: gazebo container and Clover container. Gazebo container contains task system, which generates world and check tasks, and gazebo itself, which does all simulation stuff. Clover container contains pigs4, Clover, and user program. Wait a second. Sorry. Clover container contains pigs4, CTL, Clover, and user program. Oh, that's mostly all technical details. Now I can do presentation of project itself. For example, I want to create simple workspace. This is, wait, it's, oh, cool. I have broken my setup. For example, I want to create example workspace. I run vs create test, and it already exists. Let's try another name. Oh, test one. Okay. And I want to launch it on simple fly rectangle task. No problem. I do launch. And it breaks because I have accidentally broke my whole setup. I came very prepared to this presentation. Okay, now it should work. I hope. Please work. Yeah, gazebo is opening, and here it is. I think it will lag a little bit because I'm running on battery power, and Zoom is screen sharing, and there's like 20 apps open right now. But anyway, this is a simple task. It just includes Aruka marker field 10 by 10. And do I share only presentation? Nope. Can you see gazebo right now?
Yes.
Yes, we do.
Well, someone misinformates me. Wait a little bit. I need to turn on notifications. 1 more hour. So I have already prepared code for Flare Rectangle task. We can see that now only landing completed in task. I will just open this code, and I hope I saved it not in temporary directory. To connect to Clover inside simulator, we use SSH, like in connecting like real Clover. We have Clover user, we have Clover password, we have SSH, our Clover drone assigned IP, this IP. Now I will create file with code and try to run it. And we can see that Clover is armed. It takes off and starts flying on 1 meter by 1 meter rectangle trajectory. You can see that scoring is done in real time. Copter has flew 3 points, and we got points for 3 points. Now it lands. And we can see task was completed. Also, we have another task which demonstrates possibilities of world generation with Clover Sim. It's called example task. Launch task, example task. Clover Sim will build task Clover, which will allow to use task Katkin VS package. This might take a little bit more than usual because of Zoom presentation. It's like eating all my CPU resources, I guess. Okay, it's starting. Now gazebo is appearing. And here we can see generated world by task. This task includes different position of landing point and status markers and status marker colors, different order of div color cubes, different positions of these two objects, and QR code different each time. For example, I want to create new randomization. I run a renew command inside Clover Sim and restart simulator. It's very easy to restart simulator in Clover Sim. You just write restart command and it restarts. You don't need to close gazebo window and other kind of stuff. And here we can see another field, another world generated by task. If you want to return to previous randomization, we just use rset and see that. Oh wait, it's new randomization. Okay, let's generate new one. Also, I didn't mention in presentation that workspaces could be built using workspace build command, which allows to automate testing of some different Clover projects using GitHub Actions or some kind of stuff like that. You can see another world was generated, and if you want to return to previous world, you just use rset, seed that we want to return to, restart simulator again. Wait a little bit. And we're back to world that we had previous time. Also, this task contains much more complex scoring system. Here it is. Okay, so I think I presented all main features of Clover Sim. You can ask questions, I guess.
Thank you, Maxim, for great project and excellent presentation and live demo. It's very interesting. I have a question. How to create a new task and assess scores?
Task. I mean, task creation is done via Python scripts. One of the examples of creation tasks was our team created task in like 15 minutes for NTO Flying Robotics 2022. When we participated, we don't have enough time to test on real field, and we created a simple task. We just drew field in Crete, I guess, and then added image using sim Python, and then we had task for NTO. Tasks are just directories. For example, if you want to distribute your task, you can just ask users who you want to distribute task to, just to go to task directory and run something like git clone and address to your repository of tasks. I can try to demonstrate Flying Robotics task if I will find now, or you can just go to next question.
Yeah, I think you should add some documentation.
Yeah, we have documentation how to create task. So wait a second, F11, FTL Team. There is a section in our documentation on how to create tasks. There is step-by-step guide on how to create tasks and documentation on how to use different functions. Also, you can check source code of base task and example task.
Okay, great. Yeah, I think your simulator is extremely useful for Clover projects and for online competitions. And we're happy to invite you to maybe join to organizational teams to help to organize some online competitions using your simulator. And I wish you a lot of test users who will test your simulator and maybe find some bugs and help you to improve it.
Thanks.
Thank you.
I have a question.
Yes, please.
Several questions. So who will start?
Yeah, may I ask? I have a little question.
Okay.
So I understand. I understand that you've developed great improvements to the Clover simulation. However, for me as a person who's not familiar with this technology, so would you, if you rethink and rephrase your initial idea, was there any problem that has been with the previous version? Was there anything that user wanted to achieve but he could not achieve? So you helped to solve the problem, and if there was a problem, so what problem was that?
Well, one of the problems with Clover virtual machine is very simple task support. I have stumbled on some competition that were happening. Oh, sorry, I hear some giant echo from someone. Can someone mute? I think, okay, everything is okay now. Thanks. Okay. As I was saying, I had participated in competition. I think it was Innopolis Open Robotics, where we were given a virtual machine to set up with task. There was same feature as generating worlds. There was very simple task, but the problem is setting up virtual machine isn't kind of easy. I mean, we can set up Clover Sim with just one command, and that's all. But virtual machine, you need to download file. You need to add it to VMware and then to run it. And also you will stumble upon problems such as setting up IDE inside virtual machine, because I mean, simple VS Code, I think most of people there have very good preferred IDE setups. Also, one of the main problems that Clover Sim is solving is its very high performance. First, let's say, -1 version of Clover Sim was me creating 2 years ago when I had very bad PC that wasn't able to run virtual machines at all. And also it has not much disk space, and virtual machines require a lot of disk space. So I have created -1 version of Clover Sim, and it was very high performant. It doesn't require much disk space. It was very easy to set up, and it was very cool. And it was even running on my old PC with, I guess, 2 GB of RAM and the Athlon CPU, I think so. If we will check now, I mean, it's development build, so it should take a little bit more space. Yeah, I should remove this file. If you check, oh, nope, wrong command. If you check this directory usage, it's only 14 GB, and I can have unlimited number of tasks and unlimited number of workspaces that I work on. But with virtual machines, I need to create new virtual machines, which requires at least 20 GB of disk space, and it also eats a lot of RAM because it's virtual machine. It's because of RAM. So that's all, I think.
Now I much better understand the purpose of your work, the purpose of your efforts, and I suggest you including this information in your presentation, which is crucial for people like me, and it's crucial for your presentation to like understand all of it. Thank you.
Thanks.
I also have several questions. The first, on one slide, you said when you compared native setup and virtual image, you said that simulation virtual machine image has task support. But what do you mean by that? Because you showed that you showed some tasks, interesting task implementation. But what do you mean by this? What task support does virtual machine image has?
Well, these tasks support were made by me on Innopolis Open Robotics competition. We were given virtual machine image, and there was Python script that generated worlds. Basically, our idea of tasks is a continuation of this idea. We make this more powerful, added checker support, added easier generation. But in virtual machines, I made once simple tasks. We have run a script, and it generated new world, and then we made test program on that. But there was no seed support, so we couldn't return to previous randomization. There was no checker support. Well, that's like 30% of our tasks implementation.
And I understand that your task support can check the solution for task, right? Because it's
yes,
the virtual machine image doesn't have it. Okay, so I think that your tasks implementation is kind of a separated project from the workspaces. You like presented two projects. First, simple installation of Clover simulator, and the second is kind of task support for Clover. Yes.
Well, they are kind of merged together because Clover Sim tool itself manages displaying of how task score. It manages task score, how much user have achieved, and it manages generating seeds. And also one of the important things in tasks, that tasks are basically additional overlay. All our system is built on top of overlay FS. It's like Docker containers. There is first Docker allower, then second Docker allower. Like you run with Docker file, when it builds multiple layers. Clover Sim is basically doing the same, but first layer is just operating system, Ubuntu with installed Gazebo and others. Then we have Clover Sim layer, which contains our ROS package, and then we have task layer. And when you select different task, it modifies image to add different task support. It changes this overlay.
So your task support,
there is workspace layer.
So your tasks cannot be used without your system. I mean, like separate project to have some tasks in a regular Clover simulator. So this is impossible.
Well, this is possible, but this requires different. It requires building different virtual machine for each task.
Okay, and one little question about technical implementation. So you say that this is not Docker containers, but what kind of containers? And do you just get these containers and run the regular Clover simulation software, or you had to update the Clover software some kind to run it in these containers?
Wait a second, I will form my answer. Well, we have first layer of simulation in overlay.fs. First, I will answer question, what is simulation system? Well, it's systemd and spawn. We don't use Docker for a reason that Docker doesn't support systemd services. And I think it's a very important part of Clover that you can just add services using systemctl, and that makes environment more close to real to environment on real Clover, because on Docker you can't use systemctl and stuff like that. So container system is implemented via systemd and spawn. It's a tool created by systemd, which allows you to run systemd operating systems in containers. So then, next question was, sorry, what was the next question?
Have you got to update or patch our simulation software, or you just run it as it is?
We build our own image, but instructions for building this image by ZFS is largely based on what you use inside virtual machine. I think I can.
So the code is the same as on our virtual machine.
Yeah, there were no giant modifications. Like, we didn't modify Clover code largely. We did some modifications with adding ability to allow ROS topic allow access to ROS topics from container with Clover to Gazebo. It's done via addition service, but it doesn't modify Clover code.
Okay, and I think that if to run Clover simulation in Docker, would OpenGL be supported, or it takes some additional effort, like running some virtual OpenGL or something like this?
Yeah, it's like it takes additional effort. First, -1 version of Clover Sim, which I talked a little bit earlier, used just bypassing of GPU device inside Docker container. But this requires installation of drivers. For example, I have NVIDIA, and I have to install drivers inside my container. To bypass this limitation, we use a thing called Virtual Test Server. Virtual is project aimed on bringing virtualized OpenGL. It has very similar performance. I mean, it's almost the same performance as. There's almost no performance loss. It's very high performant compared to using native GPU. But this allows to add ability to some kind of Docker container or systemd and spawn container or LXC container or even QEMU container. Add ability to access to OpenGL and Vulkan.
Okay, thank you. I like this project very much.
Yeah, I like the project too. Yeah, but I have a question. You are developing this simulator for a long time now. How many users do you have?
Well, it wasn't like very long time. How should I put it? -1 version was created 2 years ago, but then I got a new PC and I was like, okay, I will just use VM now. But the project was reborn, I think, at the start of CopterHack, when I understood that I need more complex simulations. I first wanted to work on different projects, but I stumbled across issues with Simulator VM that I, let's say, broke it 3 times and then had to reinstall it, and I was not okay with that. So instead we switched to this project. About users, mostly we use it inside our team. It's me and Mikhail and Lёша Журавель who participated in an NTO Flying Robotics. And I think maybe there's some other users, but I don't know about them. No one has contacted me yet.
Okay, and do you have any plans to promote it?
I think Oleg, wait a second. Oleg Panflinek has mentioned that it may be a great idea to start some virtual competitions based on this Clover Sim. So I think we will in future do some virtual competitions that will promote Copter Express and Clover Sim as tool to run these competitions.
Yeah, right. I mean, to use your Clover Sim on World Skills competition or some else competitions that we organize. If you're ready to help us with this, we can we can try to do it and to do it together. And also, you please promote your Clover Sim our groups and Telegram groups like support group for coax drones, and I think there will be some users who will want to test it. I'm sure this.
Jack raised his hand, so.
Yeah, hi. I just wanted to ask, I saw in your slides you mentioned the WSL support. Have you tested this in Windows or any other OS, or has it mostly been tested just natively on Linux or Ubuntu?
We have tested it on VSL 2 preview on Windows 11. I have set it up like I think a week ago. I have set up virtual machine with Windows 11 with NVIDIA GPU bypassing, and I think I can show a screenshot of VSL running. Clover Sim running inside VSL. Somewhere. Oh, well, it's here. Here is screenshot of how that looked like. As you can see, Gazebo and Qt, which was launched from a Clover container, are just like simple Windows. So Windows, like cool. So you can easily alt tab and use VS Code IDE. So it's kind of cool.
Awesome, yeah, that's very impressive. Just another quick question: the randomization. Are you just randomizing the SDF blocks you're putting in, or are you randomizing the Aruka map as well?
It depends. Aruka map can be created by users, so it can be randomized. Aruka map is automatically set up, so config for Aruka map. You think you know that Clover has config for Aruka map, so it will know where Aruka maps are placed. In case you modify Aruka map itself, you can give some different Aruka map positions and randomize them, and Clover Sim will automatically set up this Aruka map positions in Clover containers. So user just need to turn on these features in configs like aruka.launch and clover.launch. Yes, it's not by default, it's not randomized by default, but you can randomize if you want to.
Awesome, thanks. That's very impressive.
Any other questions?
Okay, thank you very much. It's very great project, and we wish you a lot of test users, and sure that we will work together next to promote the simulator. Okay, Elena, we are ready to next.
Yeah, our third team is Stereo.
Now, finally, my name is Denis, and I am the only member of Team Stereo. I always loved drones and autonomous navigation, so I decided to participate in this year's CopterHack. Next slide, please. I mentioned autonomous navigation. Autonomous navigation is cool and allows solving many real-world problems. However, the real world is often complex and contains many objects like infrastructure, buildings, power lines. If neglected, this can lead to crash if your drone does not have any ability to perceive the 3D environment. That's exactly the problem I want to solve. I want tokens, algorithm which will help flying safe autonomous missions. Next slide, please. In order to avoid the obstacles, I use artificial potential fields method. It is based on the analogy from physics, from electrostatics. This way, the copter, the goal point where we need to fly, and obstacles are assigned with electrical charges in such a way that copter is attracted to the goal point and repelled by the obstacles. This way, we can solve a simple physical problem, which will give us a safe collision-free trajectory. Next. In order to do this, we obviously need some way to perceive the world, to receive the 3D information about it. We decided to use Intel RealSense depth camera. It's especially attractive because there is a plugin for Gazebo simulator called RealSense Gazebo, which emulates this depth camera in the simulated environment. The depth camera outputs a point cloud, which is very convenient to use for potential fields computations. Now let's go a little bit next slide. Now let's go a little bit deeper into the trajectory computation process with this potential fields method. As I already said, the copter obstacles, we consider each point from point cloud as obstacles, and the goal point where we need to fly are assigned with electrical charges. Some of them repel the drone, some of them attract. For example, the repellent force, the formula for the repellent force is shown on this slide. The obstacle points from point cloud repel the vehicle, and as you can see from this formula, this force rapidly grows when the copter closes in to the obstacle. On the other side, the attraction force is constant regardless of the drone coordinates, and this was empirically found that such formula improves the flight quality. It's also important to note that each obstacle point has a limited sphere of influence. It only repels the vehicle if it's near this point. In our case, this distance is 2 meters. It is the distance threshold in the formula, and this is a hyperparameter which can be set by the user. Q repel, the charges Q repel, Q attract are also hyperparameters which can be set for different drones. In our particular project, we used a Clover 4 platform and found a set of working parameters for the Clover drone. If your drone is drastically different from the Clover, you can just launch the simulated environment, found some obstacles, and tune these parameters to find ones which suit best for you. Next slide. Now, when we have many attraction and repellent vectors, we need to sum all of them, and as a result, we will get the vector which tells where to direct a constant flight velocity. This way, we get the differential equation in terms of coordinate. It is differential equations. We just need to integrate it, and this way we get a safe collision-free trajectory. We use, it's obvious that during the field of view of the camera. To solve this problem, we dynamically recompute new local trajectories approximately 5 times per second. Our experiments show that this speed is enough for a stable flight at a moderate speed of up to 9 kilometers per hour. Now we have a safe collision-free trajectory and flight. However, it's not that simple. We can just feed the resulting equation to the autopilot, because the autopilot can only reposition and velocity set points at each time. So we need to send commands for the also show few artifacts like sawtooth patterns. These are just principal issues of numerical solving the differential equations. And as we have these small artifacts, we also need some smoothing. To solve all these issues, we developed a special trajectory following algorithm. It is schematically presented on the left side of the slide. As you can see, at each time step, we draw the imaginary sphere around the drone and find the intersection point between the sphere and the trajectory. Then, when we have this intersection point, we just direct the flight velocity, and this method gets us both smoothing and the translation to drone language of how to fly and execute this trajectory. Next slide. Now let's go to results. We have tested the algorithm in the Gazebo simulated environment, and as you can see, Copter easily navigates through the simulated environment with lots of trees at a moderate flight speed of 3 meters per second. Next slide. It can also avoid thinner obstacles like these telephone poles. However, at a small, I know the issue why this happens. Why we need slower speed to avoid thinner obstacles. It is related to point cloud downsampling. Now can on a smarter downsampling algorithm. Next. Obviously, to test this algorithm on my real drone, as you can see, the hardware part is ready. The real sense isn't this position flight mode, which is used for autonomous navigation. Currently, I am putting my efforts to solve this position flight mode issue, and when this will be solved, the copter should be ready for flight test. I hope to make this in the next month. Next. The presented code is completely object-oriented, parameterized, so you can tune it and use on other smaller or bigger drones. And all of this makes it very easy to use it in the existing environment. You can fly autonomous missions. All you need to do is just to specify a set of waypoints which you need to follow while avoiding the obstacles. This framework can be integrated into Clover environment or can be used as a ROS package for even more convenient integration. And this way helping people who want to develop autonomous missions in complex environments. Next. Now, thanks for your attention. If you have any questions, feel free to ask them.
Thank you very much. How do you simulate this real sense sensor on Gazebo?
As I already said, there is a plugin, open source plugin called RealSense Gazebo. It is based on Gazebo physics engine, and you can just clone it, build in your Katkin environment, and add it to the Clover X-Acro model and just use it. It communicates with ROS topics, and you can just connect to this topic and get a point cloud, for example.
Mm-hmm. Okay, thank you. Thank you. Oleg Kochov, please ask a question.
Maybe a little bit silly question, but why actually do you need to integrate your velocity that you get from your equations? Why you cannot just pass this velocity to velocity set point and make the drone fly and avoid obstacles and reach target?
I'm sorry, there was connection.
Hello?
Understand.
Okay, do you hear me now?
Решение уравнения как velocity set points, ну, я могу как на английском, как на русском, так удобно. Okay. I did not directly feed the velocity set points because, as I already said, sometimes there are artifacts like sawtooth patterns on the generated trajectory. It's related to numerical solving of differential equation, and if we direct feed the velocity, that's why I decided to develop a more complex trajectory execution algorithm, so it will provide some smoothing.
Okay, and one more, and maybe it's possible to smooth the velocities at points that you pass, or it would also be worse than to smooth the trajectory?
Point, I think I need to test it.
Okay.
Andrei?
Any questions?
Yes, a very interesting project. 1 second, please. Yeah, great, thanks. The project is great. I believe it's a simple yet powerful solution of the problem. But why you divide the charge of the obstacle with distance, yeah, to obstacle to get the force? Why distance and not, for example, distance squared or distance in some degree? Because in real world, if it's charges, it's divided by distance squared.
Yeah, it's just
We don't hear answer.
The artificial potential fields method is not new. It was being researched since like 60s of the 20th century, and it's just an empirical fact that this potential, this formula for force works better than the R squared. Because, for example, if your force is squared, then the force will become large enough to repel the vehicle, pull the obstacle, which is
yeah, thank you. And have you ever read Run Around by Isaac Asimov? No, maybe you should. Yeah, Karavot. Yeah, it's very close and short, entertaining.
Alexei, please ask your question.
Hello, thank you for your presentation. It was very interesting. And I have only one question. Did you test it with real drone or any other robots? Because very interesting how it worked in real life, not only in gazebo.
Алгоритм тогда, в принципе, в теории можно в параметрах автопилота ограничить угловые скорости. Ну, мне кажется, это довольно костыльное решение, потому что это сразу резко ограничит скорость полета по облету препятствий и приведет, возможно, к другим нежелательным эффектам. А так, да. Ну вот да, только если на подвесы вешать. А вот так вот, если она статически закреплена. Но подвес всегда должен сработать. Ну и плюс, вот, к слову говоря, про SLAM, про построение карты в симуляторе, там есть некоторые сложности, связанные с тем, что SLAM требуются какие-то удобные визуальные фичи, за которые можно зацепиться, которые можно сопоставлять с последовательными изображениями, и по которым, в общем-то, и строится карта, определяются координаты. Ну, такими фичами являются углы, какие-то неровности, потертости, а симулированный мир, он более идеальный, там все такое гладкое, красивое. Это, с одной стороны, хорошо, но слэму это только минус. Ему очень неудобно там работать. Только текстуры какие-то надо натягивать, да.
Okay, I can ask my question one more time. Thank you for your presentation. And my question was, did you test it in real life with real drone or other robot and how it works, not in a simulation.
The connection quality was poor. Can you please repeat your question? Have I tested on the real drone? I really wanted to test it until the CopterHack final. However, I encountered some solely engineering software issues with position flight mode, with inconsistent behavior in the position flight mode. The copter just starts flying in the random direction, and this blocks the flight test of the obstacle avoidance, because this position flight mode is used for autonomous missions, for every autonomous mission.
Mm-hmm. Okay. Next question.
Hi. I just wanted to ask, did you use this specifically for outdoor navigation, or have you tested it indoors? Because I see in your simulation you weren't using Aruka maps or anything like that. So were you using the GPS simulation in Gazebo, or perhaps optical flow or something like that?
I consider both GPS and optical flow, but I think that my first test will be done using the GPS. These demos you were seeing on my presentation were done while flying using the GPS sensor, only the GPS sensor. Tests show that solely GPS provides enough accuracy to avoid the obstacles.
Just a follow up then, did you use the Clover wrappers for navigation, like the set position services, or did you interface with Mavros directly?
You're asking about my platform, my drone, or about the firmware on my autopilot?
Yeah, no, the software. When you set position, so you generate your trajectory, but when you're commanding them to the drone itself, were you using like the set position service that you get from Clover, or were you interfacing directly with like the Mavros set point position?
Yeah, I used Clover services for both getting telemetry, sending velocity set points. Yeah, I used Clover framework.
Okay, cool. Thanks.
Does anyone have any questions?
Thank you very much. Thank you for your presentation and for project. And I think we are ready to listen to the next thing.
Our next team is Copter Clowns.
Hello everyone, do you hear me?
Yes, we do.
So, just one moment, I share my screen and we are ready to start. Oh, okay, do you see our presentation?
Yes, yes, we do. Go ahead, please.
Okay, hello everybody. The Space Clowns team is in touch. For more detailed acquaintance with the design, code, and components of our brainchild, we recommended that you follow the link to our article. We present and innovate development in the field of space communication, technologies namely Copter for Space, developed with the support of the Laureate company. Why did we put Tarantino on the title slide? Well, while we were developing the project and achieving stability in flight, the drone repeatedly beat us mentally, in the best traditions of pulp fiction. Our team members live in different regions. Some of us are already in university, while others are finishing high school. Nevertheless, we sworn at a task unprecedented to the human imagination. Here is our geography. Our purpose is creation of an engineering constructor of an L-band data receiving station based on Clover 4.2. To achieve this goal, we have solved a number of tasks, the list of which you can see on the slide, related to design, programming, and writing documentation. The impetus for the development of the project was the story of the destruction of the Arecibo radio telescope in 2020. We came up with the idea of using a drone to carry the irradiator in the focal plane of the antenna in order to reduce the number of potential failure points and simplify the maintenance of the manipulator. Why? Copter for Space, after all, a constructor, i.e. an educational product. Working with a large audience of users, young users, we will be able, firstly, to attract more people to a new topic for research. Secondly, in this way, we will open the way for creativity, thereby speeding up the program for modifying the complex. And thirdly, we take part in the formation of potential future fellow developers. Let's talk about construction. We have strengthened the Copter supports, thereby ensuring the protection of the electronics unit and also increased the survivability of the structure as a whole. The modification of the propeller group made it possible to increase the payload by 1.5 kilos. The high-capacity battery allows the quadrocopter to complete the mission for longer. Let's consider the receiving part of the complex. The signal coming from the satellite is reflected from the parabolic mirror and focused at a certain point in the focal plane, where the copter carrying the irradiator is waiting for it. The signal, passing through the low noise amplifier, enters the radio receiver and is recorded to the drive through the Raspberry. So here you can see the software scheme, and let's talk more detail. In start, we got TLE files, or satellite orbital parameters, which converts to a track file or to X and Y coordinates. Then the program creates a flight task. Then drone takes the starting position of the track, and then signal recording is starting. After that, we track the satellite, and after finishing the tracking, the drone have a land. And then we start the demodulation and decoding process, and then visualize the image in the browser. So let's see the simulation. The received data from satellites can form the basis for making short-term weather forecasts, as well as solving other problems in the field of Earth sciences. We use the following software to analyze the data, for example, Meteorlinter and Snap. After test receptions of data in Nalchik and in the Moscow region, we began to work on the stability of the flight of the copter in order to improve the accuracy of tracking satellites along the track. For example, in conditions of gusty wind and high humidity, low temperatures. Below, you can see sample photos. Since December 2021, the tests of the complex have been carried out by students of the University Gymnasium of Moscow State University. As you can see, the young man in the photo with glowing eyes is setting up the drone before test flight. Gymnasium students try to achieve maximum stability in the flight of the drone and take the image practically without distortion. Here's the example of tracking the satellite. We also wrote manuals for comfortable work with our constructor, including an interactive instruction on Gitbook and a detailed manual for working with remote sensing data. Also, all our code for working with complex is available on GitHub and GitLab. So, what about results? We wrote a whole pack with documentation for making for working with our construction, and we have registered the brand Copter for Space with support of Loret company. The design of the drone has been improved, and we improve its survivability. After all, we took part in the series of educational events, such as thematical event in FTL Team named after Pizza. And after this event, we made a decision to make a Gitbook. A new software has been created to calculate the satellite flyby schedule and in accordance with the satellite parameters to select the optimal trajectory of drone manipulator in the focal plane of the mirror. An automatical demodulator decoded based on SDAM has been adapted for Raspberry Pi 4. And what about project development? We are continuing to achieve maximum flight stability, and in our future plans for the maybe the nearest half year is adaptation of the payload model for operation at the large receiving complexes. Then we would like to adopt the payload for Coax Pelican platform for work at receiving complexes bigger than our. And we would like to experiment on simultaneous reception of signal from several satellites using several drones at the same time. Thank you for your attention. We are ready to ask to your questions.
Thank you very much for project and presentation. What is the weight of receiving hardware, and what is the total flight weight of drone with this hardware together?
Thank you for your question. In this question, we'll ask my colleague Ilya Khaladilov. He is in auditory now.
Sorry, could you please repeat your question?
Yes. What is the weight of satellite signals receiving hardware, and what is the total takeoff weight of drone?
Сколько у вас весит приемник антенны и, соответственно, общий комплект?
I cannot hear the answer. I cannot hear.
The satellite receiver weighs around 600 grams. Так, а общий дрон?
Полезная нагрузка весит около 600 грамм, то есть это много приема и аккумулятор по увеличенной мощности весит порядка 400 грамм. Весь дрон в сборе весит около килограмм 600 грамм, а обычный клеток весит порядка 800. И за счет спецификации полезной нагрузки, модификации моторной группы, мы добились того, что он стабильно летает при 42% мощности около 4 минут.
Okay, so continuing to answer this question, the total weight of the drone with the equipment installed is 1 kilogram, 600 grams. it is almost twice as much as regular Clover, but the guys have modified the battery and installed different motors, and that gave them the ability to hover at 42% gas, and the flight time is around 4 minutes.
Okay, thank you. And this receiving hardware, is it available to purchase? And what is the price?
Sorry, we hear the first part of the question. What is available to purchase?
Yeah, this receiving hardware. Can I buy it? Well, what is the price?
Я могу ответить. Ну, собственно, полезная нагрузка, собственно, состоит из облучателя. Вот этого вот фрагмента. Он изготавливается на данный момент вручную. При необходимости его можно повторить самостоятельно. Здесь используется шпилька М3, несколько гаек. И вот такие вот, ну, так скажем, блинчики, да, они изготовлены из, сейчас, если не ошибаюсь, из алюминия, также могут быть изготовлены из фольгированного текстолита. Также здесь есть из приемной части SDR-приемник AirSpy. У него цена, если не ошибаюсь, около 20 тысяч рублей. При необходимости можно найти дешевле сейчас на AliExpress. Вот. Существуют модификации без металлического корпуса в виде просто печатной платы. Они, соответственно, дешевле. Также сейчас здесь есть, я не знаю, видно, нет, вот эта вот серебристая коробочка, это тройник смещения, такой фрагмент, который нам позволяет по одному кабелю давать и данные, и питание для усилителя. И вот здесь вот, такая вот серая коробочка. Это малошумящий усилитель, самый дорогой фрагмент в приемной части. Он стоит порядка 40 тысяч рублей, но он здесь взят с значительным запасом и может быть удешевлен.
То есть общая сумма полезной нагрузки составляет примерно
70, наверное.
70 тысяч, получается, полезная нагрузка. Стоит также мотор.
Okay. I understood. So the total price of this receiving hardware is 70,000 rubles. And the last question for me about your testing outside testing in fields. Do I understand correctly that you have performed 2 tests and both of them don't reach the goals and you can't receive signal from the satellite?
Тестирование проводились как помещение на улице, и на улице с командой ребят мы проводили тестирование. И во время как раз этих полетов у нас происходили проблемы с ветром, который мешает принимать данные, так как у нас дрон должен находиться в необходимой точке с поверхностью плюс-минус 2 сантиметра. И из-за этого во время тестов мы установили защитный кубик вокруг летной зоны, обтянули его специальной пленкой, чтобы не оставались лишние воздушные потоки. И при этих значениях, при этой ситуации он летал стабильно и более-менее попадал в нужные зоны и принимал сигнал. Также мы пробовали его без куба. Он все равно летал более-менее стабильно, но за счет того, что мы еще не до конца настроили параметр precision, то есть полетные MPC, это значение для X и Y, не так же будет сейчас пополняться, обновляться, и за счет этого он будет более стабильно летать без защитного куба. В принципе, тесты проводились, и значения мы получали, снимок сигнала также был.
И если это все сократить, у вас, получается, полеты были с опорой на руку. So answering
also, I would like to add
the outdoor tests were performed. However, the team needed to erect the cube, a protected cube, so that the wind didn't influence the drone stability too much. But they believe that if they continue performing the tests to adjust the flight parameters, they could be able to find There's such parameters that will allow to fly without the protected cube. Oleg, we're not hearing you, sorry.
Yeah. Thank you very much for answering. And the next question from Alexei Shlupin.
Hello, thank you for your presentation. I have a question about your project. Why do we need to change manipulator for drone? Because it's not so easy to put drone in point exactly on the mirror of to take signal from satellite. Is it a good idea? Why nobody do it like you want right now?
Я начал понял, можно...
Хорошо, да, по-русски. Почему никто так не делает? Ведь дрон, то есть много очень сложностей с позиционированием дрона. То есть почему нужно заменять вот этот манипулятор на дрон, если дрон очень сложно спозиционировать, и, собственно, вот тесты тоже не сработали? Вот.
Я попрошу переключиться, наверное, на презентацию. Есть возможность?
Да, конечно.
Сначала на слайд, где у нас зеркало нашей антенны. Да, можно вот этот, где анимация, не страшно. Как вы можете видеть, сейчас, открой, пожалуйста, слайд, где анимация, да, вот это. Как вы можете видеть, здесь у нас относительно небольшое зеркало, там диаметр 1,1 метра. Он используется для удобства тестирования. Вообще наша история предполагает использование на зеркалах с большим диаметром. Можно на слайд с ресибой. Ярким примером является радиотелескоп Росиба, который был заброшен за счет того, что у него там диаметр идет счет на десятки метров, если не ошибаюсь, счет там 50 или даже больше метров. И вот на верхнем изображении видно, как выглядит манипулятор. Это система тросов, которые довольно ненадежные, которые сложно обслуживать. А для зеркал такого типа позиционирование дрона должно быть, имеет уже не такие, так скажем, погрешности, то есть мы должны там позиционироваться в порядка хотя бы сантиметров 30, в отличие от 2 сантиметров, как сейчас. Вот. И
то
дрон...
есть с РТК это вообще должно работать достаточно четко.
То есть у нас задумка проекта в том, что мы сейчас делаем на более уменьшенной версии, грубо говоря, тестируем все возможные проблемы сети, и в дальнейшем планируем как раз таки, если найдем площадку, на которой можно тестировать, как раз таки масштабировать этот проект на более больших зеркалах, на которых погрешность уже не так важна, но если произойдет поломка манипулятора, то данное мероприятие придется закрывать и создавать новое. То есть в этом основная задумка, то что дрон, даже если сломается, его можно заменить довольно быстро и просто, а если сломается манипулятор, то придется перестраивать все строение.
Еще переход к большому зеркалу решит некоторую проблему, то что сейчас, когда у нас рефлектор антенны нашей небольшой находится достаточно близко от того, что потоки воздуха от дрона, так скажем, соударяются с рефлектором, и создаются потоки, которые нам мешают двигаться. На больших зеркалах такой проблемы не будет.
Да, спасибо большое, это понял. А все-таки почему сейчас так не делают? Вроде манипуляторы не так часто падают на зеркала. То есть это не прям такая частая катастрофа.
Во многом это из-за счет того, что подобных строений не очень много.
А сколько вообще их в мире таких строений?
Возможно, на этот вопрос лучше Тимур ответит, но не уверен сейчас.
Андрей, спасибо. В целом, количество подобных сооружений не превышает 1 десятка. Может быть, 12 или 13 штук. Но, тем не менее, на данный момент в Китае построены, запущены в эксплуатацию крупнейший на данный момент радиотелескоп в мире. И для того, чтобы он, соответственно, прослужил дольше, возможно модифицировать его под работу непосредственно с системой дронов для переноса облучателя.
Окей, спасибо большое.
А где еще могут применяться такие ваши системы?
В том числе на штатных приемных комплексах на Земле. То есть, в конце концов, дрон занимает в кейсе место меньше, чем условные опоры, на которые крепится манипулятор, то есть роботизированная рука. Соответственно, это минус дополнительные килограммы и плюс к мобильности комплекса. То есть, соответственно, его можно легче перевозить, и, в принципе, установка комплекса будет занимать меньше времени.
Ну, вроде зеркало не так уж легко перевести, оно же достаточно большое.
Зеркало достаточно большое, но инженеры компании Лорет в лице Ярослава Мухадинова проработали систему складного зеркала. То есть зеркало состоит из небольших компонентов, которые легко в разобранном виде вставляются в небольшом кейсе.
Продемонстрировать на презентации. Если не ошибаюсь, 2 слайда назад. Нет, еще. Там еще дальше было. Еще. Вот, да. Вот на левом изображении вы видите в разобранном виде наше параболическое зеркало. То есть оно изготавливается на термовакуумном станке из пластика, выдавливаются такие лепестки. На эти лепестки наклеивается отражающий элемент из медной сетки, да? А впоследствии эти лепестки просто винтами соединяются. Тем самым получается ровное параболическое зеркало.
И данная конструкция в данной аппликации занимает один кейс размером 50 на 100, и высотой тоже примерно
50. So translating this conversation in short, the guys decided to develop this flying robotics platform. That's to first increase maneuverability, so that it could be transferred anywhere. Then the maintenance of the flying antenna carrier would be way easier than maintenance of a classic antenna carrier, which is used currently in, was used in Arecibo and is currently used in different projects of such mirrors, which are in total 10 to 12. That's it.
Okay.
May I have a question?
Alexander, okay.
Yeah, thank you. So did you consider using the positioning system based on ground control points and RTK instead of optical flow? And if yes, so at which size of the mirror the optical flow will become less efficient and the RTK will become more efficient, starting from which size? Was that clear? Did you get my questions?
Да, мы рассматривали модуль как раз для дальнейшего. Сейчас его не смотрим, потому что он довольно долгосрочный. Идут одноприемные тексты порядка 70 тысяч.
I can't hear you guys.
I'll translate it a bit later. There are some problems with the sound.
Hey.
Hi guys.
Hello.
Can you hear the presenters?
No, there's no sound. I can hear you, Ilya.
Oh, that's sweet.
Сейчас, я надеюсь, вы нас слышите?
Да.
Так, я не понимаю. Мы также рассматривали модуль РТК для дальнейшего применение, но сейчас мы его не используем, так как он очень дорогостоящий, так как нам необходимо как минимум 2 антенны, что в сумме будет стоить порядка 120 тысяч при нынешнем курсе рублей. Мы рассматривали эти датчики при хороших условиях. У них погрешность примерно плюс-минус 4-5 сантиметров, что на данной модификации для нас не сильно устраивает. Но при увеличении зеркала порядка... Сейчас, да.
Так при каком размере зеркала это будет возможно использовать? Такой точности будет достаточно. Просто не слышно.
Ярослав, включайте.
Добрый день, коллеги. Меня слышно?
Да.
Хорошо, супер. То есть у нас получается то, что на зеркале размером порядка метра у нас пятно фокусировочное, оно составляет порядка 10 сантиметров, ну и, соответственно, нам надо позиционироваться с точностью плюс-минус сантиметр, чтобы попадать ровно в центр этого пятна. Вот. При увеличении, условно, зеркала в, получается, порядка 10 раз, у нас получается уже пятно несколько больше, то есть оно составляет порядка уже полуметра, вот, и у него наибольшая энергетика достигается именно в центре, ну и, соответственно, нам уже вполне достаточно точности позиционирования, там, которую нам предоставляет либо RTK-шный GPS, вот, либо как раз-таки система Optica Flow. Вот. При очень большом зеркале, в какой момент, от какого размера зеркала система Optical Flow уступит по точности RTK? Я так понимаю, это будет уже при размерах зеркала порядка 100-150 метров. Вот, когда уже само зеркало мы будем очень, так сказать, в общих чертах и не сможем наиболее точно позиционироваться.
Спасибо. И у меня есть последний вопрос. Как обеспечить непрерывность приема сигнала, когда батарейка сядет? So, how do you ensure continuous reception of signal with the circumstance when the battery on the drone is done and it needs to be replaced?
Ты думаешь,
у нас в зале есть ответ.
Так, ладно, попишешь.
Да, можно применять либо рывое применение дронов, то есть можно запускать несколько дронов, если у нас увеличивается зеркало и необходимо принимать сигнал уже не 3 минуты, а, допустим, 10, привязать там, допустим, 3 дрона, чтобы они на разных участках производили пролет и принимали данные. Потом эти данные просто склеивать также и декодировать. Или, опять же, использовать дроны больших размеров, такие как, допустим, Пеликан, или еще больше, такие как DJI-евские промышленные дроны, и на них также производить прием этих данных.
Спасибо.
Okay, thank you. Jacques, your question, please.
Hi, yeah, I just wanted to ask about how you've attached the irradiator or the receiving antenna to the bottom of the drone. I see it's mounted like solidly. And for example, when you're going across like a bigger reflector, won't the angle start influencing your reception? So because the way I understand it is you want to be in a precise position to get the signal. So if you're in motion and you're tilted sideways, now your antenna is tilted sideways as well. Would there be any benefit in adding something like a gimbal or something that ensures the antenna is pointing in the right direction, regardless of what the drone is doing.
Ребята, вы обдумывали тот факт, что когда у вас дрон летает, он будет не идеально в горизонте летать, а сноситься, соответственно, у вас будет случаться фокус. Не фокус, обдумывали ли, что можно добавить информацию?
Давайте я скажу чуть-чуть немножко. Давайте я сначала немного скажу. Меня слышно. Мы знаем о том, что, ну, то есть мы учитываем то, что у нас дрон отклоняется во время полета, но по работе алгоритма, как принимаются у нас данные, нам необходимо в определенную секунду времени находиться в определенной точке. То есть мы между вот этими секундами можем просто пролетать и спокойно находиться в негоризонтальном положении. При, опять же, стабильных улучшенных параметрах он будет находиться в этом положении и принимать данные. Также при данной антенне у нас есть угол порядка 7 градусов отклонения краски по осям, который нам и дает прием данных при данных сейчас условиях. Но в дальнейшем мы, конечно же, планируем применять двухосевой стабилизатор для того, чтобы антенна находилась постоянно направлена по горизонту вниз и принимала данные намного лучше и эффективнее. И Ярослав может сейчас, в принципе, показать сейчас примерный вид, как они могут. Да.
Okay, so answering Jacques' question, the algorithm that the team developed now allows has the following structure. So basically, the drone has to be in certain points at a certain time. The position of the drone between these set time frames is irrelevant. So basically, that's it, how it's solved. Then another thing they've thought over is that the physics they've checked shows that the drone could have an angle up to 7 degrees from the horizontal flight, and it will not influence the results. But later, they plan to add the stabilized gimbal, probably.
Okay, thank you.
Okay, and last question from Andrew.
Окей. Мы в общую группу в Телеграме по CopterHack загрузили фотографии как раз-таки с дальнейшей модификацией, с стабилизатором.
Yeah, I was going to ask about necessary angular precision of the attitude of the irradiator too. So I don't think that you have to put it vertically in all the points of the trajectory. What is the maximum required attitude of the irradiator? Or do you need to put it vertically always? Да, вам вообще под каким углом нужно, чтобы вот этот вот облучатель находился? Он же не всегда должен быть направлен прямо вниз. Под насколько большим углом он должен быть направлен, если вы где-то сбоку тарелки снимаете?
Мы должны всегда находиться вертикально вниз.
Всегда вертикально вниз.
Да, и как раз таки по прошлому вопросу у нас есть 7 градусов отклонения, которые мы можем еще...
Ну, в идеале всегда просто
вертикально вниз, да, всегда. Так и построено, в принципе, отражающее зеркало, что мы должны находиться ровно в этой плоскости всегда.
Спасибо. И еще вопрос. Можно вот слайд с Аресиба, это ну, огромное зеркало. Вот, это до и после падения квадрокоптера, правильно?
Ну, не квадрокоптера, а...
Так вот, мой вопрос, это если квадрокоптер упадет на зеркало, то какие последствия?
Зеркало изготовлено из материала футона, я думаю, зеркало это ничего не будет постоянно.
Спасибо.
Кажется, там был вопрос.
Да, вопрос.
Я вторую часть только. Translating the second part of Andrew's question, it was what would happen if the drone actually collides the mirror, and the team believes that nothing would happen to the mirror because it's made from concrete, and the only thing which would be demolished would be actually the drone itself.
Okay, thank you very much. Thank you, team, for the project. It's very interesting, and wish you the best with developing this project in the future. So, Elena, what's going to be next today? Please tell us.
So, our next team is DJS Phoenix. Are you ready?
Yes, we are.
Great.
Hello, everyone. A very warm greeting from DJS Phoenix. We are the official drone team of DJ Sangvi College of Engineering, Mumbai, India. We are a group of students who design, analyze, manufacture, assemble, and pilot different types of drones. Our motto is to develop, improve, and explore the territory of drones. We have a community formed by gathering drone enthusiasts having interest in various fields. Our team is a multidisciplinary, that is, it has several departments. We are a small team with just 11 members who helped us in successfully making our first autonomous drone. The various departments involved in making our project are mechanical, electronics, coding, marketing, and aviation. Moving on to our project, we have the autonomous valet parking drone Ikshana. As it is clear from the heading, our drone Ikshana helps the driver in finding a free parking spot in huge parking space. Ikshana is a Sanskrit word which means sight, care, and superintendent. Our drone, with all its features, can be said to have a good sight for finding empty parking spaces, hence the name Ikshana. Now let's head on to the work done by various departments of our team. First, we have Harshal Varde representing the mechanical department.
Now I'll be telling you all what has been done in the mechanical department of DJS Phoenix in the creation of Ikshana. So we first started off with the selection of drone frame and we chose HX. The reason for that is that it provides a good stability and its compact shape helps in the placement of all the components properly. It also weighs less and we have also added some more fabrications to reduce the weight. Now that the frame was chosen, we decided that the material we will be using is carbon fiber. Carbon fiber weighs less and has a lot of strength. Later, the CADs for the drone assembly were made using SolidWorks and Fusion 360. We designed the frame along with all the necessary holes for fasteners and with the right tolerances. The CAD files for the same have been provided on our GitHub. We have also 3D printed Raspberry Pi case and damper frame. The CADs for them were made on SolidWorks and the slicing application used for 3D printing was Cura. The material used here was TPU with regards to its flexibility. Now Ankit Sawant will be explaining about the electronics department. Over to you, Ankit.
Let's move on to DJS Phoenix Electronics Department. We work with the mechanical department in an integrated manner. Let's look at Ikshana's electronics. Almost all of the components explain themselves. The flight controller we used was the Pixoc 4, which is an open source autopilot stack. We have written OpenCV script on the RPi on which the cameras are connected. We have used the LiDAR to maintain the altitude. The batteries used are 4S LiPo batteries. Now, Khushi Sangvi will be explaining about the coding department. Over to you, Khushi.
Okay, so this is the workflow of Ikshana you all can see in the PPT. First, we have downloaded the firmware and flashed the image inside the SD card of Raspberry Pi to get the access of the Clover platform. We have set up RPi and Pixoc to allow communication between both. We have also used QGC via Wi-Fi. In case of automation failure, we have set up the alternate method by manual mode. So now the setup is over, and as you all can see in the PPT, process 5, 6, 7 are the operations our drone will perform. Ruko map detection. Clover platform has provided the code and configuration. We have just set up that according to our convenience. LED blinking. The car will come to know in which direction he wants to go with the help of LEDs. Like if all the LEDs are red, the car should stop. If all the LEDs are green, car should move straight. If LEDs glow only right side of the drone's arm, the car has to turn right, likewise for left. If rainbow color is there, then the parking is done. We have used OpenCV for detection of cars. The code is provided in the Git book, and this way Atena will guide a car to reach the marking spot. Here's the demo video. Now you will be thinking about the cost of our drone. So here's my friend Shub, who is going to tell you about the cost.
The expenditure was one of the hardest tasks for us, as we were making an autonomous drone for the first time. Hearing the reviews from other people and also on the Google, we had those who had already made an autonomous drone. We saw their budgets, and after seeing that, we were literally shocked. So we decided to make a drone that even a layman with a small budget can make it in either his house or in a warehouse where he must be working. So for that, we needed some reliable products. That is low cost but best in the quality. And so this is our product list and cost attached to it in INR and ruble. And we made our drone finally in the budget of 26,815 rupees, that when converted to ruble are 26,955 ruble. Now, my teammate Parth Savajani will give the overview of today's presentation.
Thank you, sir. To bring things to a close, let me quickly run you through the summary. First, mechanical crew. They did everything from selecting frames to making assembly in the CAD. Next comes the electronic crew. They chose electronic components, calibrated them, and at last completed their mission planning with the help of QGC software. Next is the coding crew, who automated the drone and made the drone capable to perform various operations. And here comes our last crew, marketing crew, in which we discuss about the overall budget required to build our project, Atena. That's all, ladies and gentlemen, what our team wants to offer. In addition to it, I would like to thank COEX to provide such an environment where we could automate our drone. Let's have a look at our journey of Atena video. Hope you like the video. You can connect with us through our social media handles. And thus concluding, gravity is just a number when you have 4 wings. Thank you. We are open to any questions or queries.
Thank you very much. The presentation is great and project very interesting. Please tell us a little more about how do you recognize cars, how you detect cars and parking slots, about software.
So basically, we have used OpenCV to detect the cars. OpenCV is a Python library. So with the help of that, we have detected cars. We have made XML files just as in how it will identify the cars for that. Yeah. The code is provided in the Git book. Yeah.
Sorry, I little missed to understand. XML file with what? With you have some
data.
deep learning
Data
network.
is, sorry, can you just repeat the question? Can you just repeat the question?
Alec asked if you have some deep learning or something like this. I believe she asked this.
Yes, through YouTube videos and everything, we studied about the OpenCV, and yeah.
So okay, you use OpenCV for detect some objects, geometry,
yeah.
right? And
Yes.
and what about recognition of cars? Is it car or maybe just some box people?
No,
Do you have
actually,
some deep learning algorithm?
yes. In the Gitbook also, we have provided the XML files in which the camera can, it can detect that the particular thing is car only, not the other object.
Sorry, can you please repeat? Detect only what? Can detect only what?
Well, actually, I would like to add to her answer. Like, we have already created the models. We have got the models from the Google, Internet, all the sources. We train those models. We use OpenCV as one of the platform to detect the cars, like how it will be looking from all the angles. And to detect those cars, we have already connected two cameras. One of the camera will be facing bottom, that will be sending our RO2 text, and another will be front-facing camera that will be seen by the drone. Another camera will be attached to the back of the drone, which will be again doing the image processing on using the OpenCV backgrounds and other deep learning processes, where we will come to the conclusion that the car is following our drone or not. So on that basis, the drone will move ahead, or it will stay on the same plane unless until the car or the object you say for that specific code is inclined within that specific range.
Okay, thank you. Any other questions? Please, Alexander, your question, please.
No sound.
Okay, sorry. Can you hear me now?
Yeah,
yes.
We do.
How this practical application looks from the point of driver? How how it helps to save time, and how drone finds an empty spot before the driver can see it?
Practically, it is very difficult because there are a lot of cars coming in the valet parking. So for that, we are looking for a swarm of drones that as in we will
I guess you have some connectivity issues. Let's take a scenario. Okay, a person is at a parking lot. Okay, right now he's a driver and he is searching for a parking valet where he can park his car. The best optimum way will be he drives his car throughout the parking lot and randomly gets a parking lot. In that case, he gets a parking space. But if he has a drone, he can easily go and find out the specific parking space that is available by using our project Ikshana. Since once our drone is launched, it will start finding for the optimal and nearest empty spaces that are available. But before starting with that, one has to install all those RO tags in a specific formation so that the Ikshana can scan the tags and come to a conclusion that so and so parking space are empty or filled. If the tags are scanned, it simply means that the parking spaces are empty and one can go and drive to them. So if that's the case where the parking lots are empty, Ikshana will drive back to the start point. It will guide the driver using the LED lights that we have installed in forums. So for that, we have,
So the driver then follows the drone
Yes, exactly. The driver
so,
follows the drone.
So what is the purpose of having left and right LEDs on the drone if the driver still follows it, and then it can?
Yeah. So there might be a case where the driver is driving at evening. Okay. So for that we have provided LEDs. During that time, driver the main observation thing that will be observed by a driver will be the lights. Following the lights is much easier than following a drone in the night. So for that, we have given the LEDs. Each LED works as specified their program. Well, for the left arm, it will signal as left. For right arm, it will signal as right. If the drone has reached the area, both the LEDs will color in with pure or rainbow color.
Okay. And last question. In the United States, I've seen the parking systems are equipped with just stationary LED panels, showing the driver the number of empty slots at the entrance to each parking aisle. And how is your system better than just local sign showing there's like 2 empty spots here, and then the driver can find them himself?
Okay, so in such cases, you never know that is there any another driver there or not. Whenever driver enters their parking system, he or she might just see that specific board, but there might be chances that there is a driver ahead or her who's already going towards that specific space.
Yes.
So if that's the case, then there will be a unlucky chance where that specific driver won't get that space because there's already a driver who's going to reach that space. And in such cases, our drone will help that specific driver to reach as soon as possible. Because we know that drones are much faster when compared to the speed while returning to the start point and while going to the specific point. So it can show the path to the driver, optimum path, like from left to right, which is the shortest distance to the nearest parking space. And that can reduce the traffic system or traffic that is being generated in the parking space or parking area. So
are you picturing more than one drone working at the parking lot, like guiding one car after another?
Yeah. That's one of our future goals, to create a swarm of drones where few of them will be the master, and they will be guiding the other drone, saying which one is empty and guide which car to specific space. So as of now, we are just focused on a single parking area where within a row, at max 3 cars can enter, and each car will be designed by a single drone. And all this process is completed within a minute, depending on the driver's speed.
Thank you.
Hi,
Jacques, please.
Yeah, sorry, just a quick question. Do you guys have a data structure or something that you're keeping track of available and occupied parking spaces, or are you searching for a parking space every time there's a car coming into it? So like if a car approaches the parking situation, do you have to then each time go and search for a spot, or are you storing some sort of information about which spots are open and which are occupied?
Yes, we are storing the data. Before the start of this entrance of these cars, our drone will take a quick scan of the whole area. Within this scan, it will take the data of all the RCO tags which already are there, which can be easily seen, which gives us indication that yes, these parking lots are empty. Once this data has been done and stored within our code, then the drone will start giving the directions to each one of the driver that's one by one coming line. So in that case, yeah. Any other questions?
Thank you. Any other questions? Please. Yeah.
Yes. Thanks for a wonderful presentation. That was really interesting. I had a question. Do you plan that these drones would be sold to the car drivers or the parking lot administration?
Sorry, can you just pardon the question?
Do you plan these? Do you plan these drones you've developed to be sold to the parking lot administration or to the drivers that they use it? Who's your customer?
Totally, yeah. So our main target audience are the big corporates where there is a big parking lot systems. Like we have malls, theaters, or any public spaces where usually there is a lot of parking space available and where one have to park a car. Apart from that, our target audience are the individuals, where Aruba tags would be used, only the open CV part will be used where the cars are being detected and then empty space is being detected. So we have both the models. The first model is where there will be a little bit of maintenance for let's say for the Aruba tags, where the Aruba tags might have been scratched by the tires or wear or torn out. So for that case, we have to just go and replace the Aruba tags. While in the Model 2, we are just targeting an individual driver. In that case, the maintenance part will be the batteries or some LEDs. So yeah, we are planning to commercialize our drone for both the target or single individual as well as the big corporates. Keeping one thing in mind that our project is solely open source, so that every time anyone who gets idea to modify it can easily come and modify our project and make it much better in some or the other way, because we all know that many minds together on a single project can make it the best, but a single mind on many projects can lead to a fumble situation.
Lots. Thanks a lot.
Thank you, Alexander. One more question.
I have a question.
Please.
Is it the same drone detecting the free parking spot and guiding the driver, or these are meant to be separate drones?
No, it will be the same drone who will guide the driver to specific parking lot. So it's that in that case, we are just focusing on the optimum solution, not where the drone is giving some data to another drone and another drone is going to someone other. We don't want that big network to be formed. So that the driver will, yeah.
In this case, the drone will spend time traveling from the parking spot back to the driver and then guiding. So this.
Yeah. So what we have observed till now is from start point to an empty point, it takes the time that is solemnly consumed by a driver, because the drone works at a speed of a driver, because at the end of the project, the driver has to follow the drone and drone has to keep one thing in mind: the driver has to be always behind it. The other way around, from the empty space to the start point where the drone has started and from where the cars are being entered, with that distance or that speed will be extremely less, because the speed of the drone will be much faster, because this time drone knows no one is following it. So its target goal will be to go back to the start point in the least amount of time.
Thank you.
So our whole process gets completed within a minute or two. Totally depending upon the driver, how much it takes to reach to the empty space following the drone.
Appreciate this.
Any questions?
Ilya, do you have a question? You raised your hand.
No, there are more questions here.
Okay. Okay, thank you guys. Thank you for the presentation and project.
Thank you so much.
It's very nice to see it. Appreciate you.
Thank you.
Yeah, thank you.
And our next team is Clover Rescue Team.
Hello, competitors of the CopterHack. Hello, jury. Today we're going to tell about our project. We are Clover Rescue Team. I am Roman Subertsov.
I am Mikhail Kuznetsov.
I am Daniel Oreshin. And I am Kirill Lyshinsky. While drones operating, users may face some problems and inconveniences. For example, during the flight, the radio may suddenly run out of power. The drone may fly away and lose the radio signal.
Also, a situation may occur when you need to upload a code to the Clover or land it when it's out of access to the Raspberry Pi Wi-Fi network. So we decided to create a website which solves all these problems. And now you can scan this QR code to go to it.
Если порядок, то, наверное, можно выбрать.
Good. It makes it possible to monitor the airborne position, the image from the camera, the geoposition of the drone, as well as upload autonomous flight mission to it or urgently land, cover, disarm, and return to user's position. And now we can demonstrate it.
This is our website. There's a map showing the user's location and the location of their drone. 3D visualization of the copter, and you can see that it moves. And its status here, connected and disarmed. Also, the function to get a photo. And from this drone camera. There's a photo from this drone. And the form to upload an autonomous flight mission to the drone. There's a simple code. And we can upload this code to the virtual drone. And Gazebo didn't work. Okay. But Gazebo don't work, so we can demonstrate on the video. So what's okay? This is hover function. When we press this, drone will hover, and land button, and photo, design function, designs, and mission upload. You can see how it works. And drone flying. And there also demonstration. We will demonstrate a return function. And as you can see, there are also available a mobile version of our website. Copter started flying to our coordinates. And on the settings, you can choose the speed and altitude of the return function. And the position of the drone and the user updating in real time, and copter lens. So how it works? Our main server and the server that installs on the user's Clover are not JS servers. After initialization, the server on the Clover connects to the main one and adds to the room with the user UID, and then it sends to this room telemetry, photos, mission outputs, and so on through sockets. And Clover site server listens to this room for comments from the user. The user adds to the room of his account UID when the page is loaded, and then receives and displays incoming telemetry from the drone.
We see our future cooperation with colleagues in the field where the company drones are used most often. The competence of UAV operating in the world is movement, because our website makes working with autonomous flight much easier and faster. What is the potential of our project? The project is very scalable, as evidenced by our bot in the Vega social network, which has almost the same functionality as the website. Therefore, there is no limit to development, so we will continue to work on the project and plan to add
a built-in code editor, an API for working with our server, as well as our own drone swarm management system. That's all. Thanks for your attention. We are ready to answer your questions.
Thank you, guys. Yeah, great project. Great job. So, as I understand correctly, you are going to create the workplace on your website and internet, and allow users to do a lot of things from your website, so they don't need to connect to Clover by Wi-Fi. They just can upload code from your website and in future we will get some additional instruments to control swarm of drones and so on, right?
Yes.
Yep.
Yes.
Yes.
Okay, yeah, it's interesting. Alec, please, do you have any question?
Okay, thank you for the presentation. The first question is, what is the link you use? I mean, how the drone is getting connected to the internet, and how do you make this connection stable?
We use Wi-Fi modem that installs to the Raspberry Pi.
Wi-Fi modem?
Wi-Fi modem. USB Wi-Fi modem. Just Beeline. And it connects to our servers through socket.
You mean 4G modem, not Wi-Fi?
4G modem, mobile internet.
And you get a stable connection and so on. Yes.
Yes. Yes.
And my second question, it was mentioned a little bit in your article, but I will answer it anyway. Why do you need a middle point in your architecture? I mean, why can this web interface just be served from the Clover itself? So the user just would get access to it using VPN. This way it would be more convenient, because I would be able to have the same interface through internet, through VPN, or I can connect to the same interface just through local network, through Wi-Fi, and I don't need any server for this.
Можешь по-русски сказать?
One moment.
Можно и по-русски.
Можно по-русски ответить?
Можно, естественно.
Ну, получается, на нашем сайте можно зарегистрировать аккаунт, то есть это делается как? Регистрируешься, все, ставишь сервер на Clover, и ты можешь управлять. Это намного быстрее, чем какой-то VPN поднимать, подключаться через него каждый раз. Есть вариант через QGround это делать, то есть подобного функционала можно добиться с помощью сразу нескольких приложений. То есть это путь WinCP и QGround. То есть если их соединить, то получится как бы наш сайт. И делать это все довольно неудобно. А у нас же все централизировано и довольно быстро, и как бы уровень входа тоже довольно низкий.
Нет, смотрите, у вас же на дроне запускается какой-то скрипт в любом случае, да? Да. Ну, какая-то программа. То есть эта программа, она могла бы и к VPN точно так же подключаться. Ну, может быть, то есть я не совсем понял вот эта вот точка в виде сервера, что она дает, ну вот, так скажем, по существу. То есть она, то есть вы говорите, что сложнее настроить VPN. На самом деле, если это скрипт, то это одинаково, что VPN поднять, чтобы подключиться к вашему сервису. То есть по существу, зачем эта средняя точка, я вот не очень понимаю. Хотя я вот сейчас уже придумал ответ, но давайте вы все равно ответите.
Так. какой вы ответ придумали?
Нет, ну можно на самом деле было бы парировать мой аргумент с тем, что вот я буду больше трафика с этого дрона получать, если это будет веб-интерфейс раздаваться сразу с дрона. А у вас, дескать, какой-то супер сжатый, очень такой маленький трафик к вашему сервису идет, а большой уже трафик к браузеру. Вот так можно было бы ответить.
Ну, да, еще я бы сказал, что, может быть, мощности разы может не хватить.
Да. Там же сервер на нашем клевере, он отправляет только сокеты. То есть там просто несколько байт, и это не жрет интернет, и никакую практически нагрузку не дает. А если VPN там поднимать, ну это да, это намного больше затраты будут. И еще есть варианты, что на Raspberry 3 не будет работать, потому что Raspberry 3 она по мощностям меньше. Вот.
Угу. Ну, ладно, спасибо.
Okay, next question, please, Alexander.
No sound.
Yeah, Alexander, we don't hear you.
I'm sorry again. So I can see what you guys are doing, but the question is, how is your software different compared to well-known software called Mission Planner? Okay, so we all know that Mission Planner can connect to the drone through IP and internet as well, and you can use guided mode in Mission Planner and guide your drone with using buttons just as your software. So what makes your software different from
Mission Planner provides only part of our functional. Mission Planner has a map showing the Clover position, and you can run mission through Mission Planner. But from our website, you can get photo from the Clover to see what's around the Clover. You can extremely fast land it, hover, disarm, and there's also visualization of the Clover. You can see maybe Clover is upside down and so
on. So Mission Planner also provides you with the controls to hover, land, takeoff, and way more. You cannot take a photo, I think, but you can make a photo even, because you also have access to different servo channels from Mission Planner as well, guys. So I would argue about that. Visualization, also
our website available from any device in one moment. You don't need to download any application from the App Store and Google Play. You can quickly move to it, go to it through your website or browser.
So cross-platform, cross-platforming and availability from the mobile devices. That's what I see for now is the most different. But however, there is a lot that is already done in this instance. So this is my opinion. But thank you anyway. Thank you.
Any other questions? Okay, I have one more question. How can we help you to support, to promote this your solution, and how can we cooperate? What do you think?
Нам нужно просто время на разработку для роли. Нам потренироваться совместно и все. Что просто совместное взаимодействие. Some collaborations with coils and sometimes just a little bit of knowledge about swarms, and so we think we can create this project
Вас очень плохо слышно.
Ну тогда просто расскажи, что там.
Да, расскажите по-русски, но громче вообще не слышно.
А по-русски можно?
Да.
Ну, получается, нам нужно время на разработку и технологии. Например, мы хотим дальше развиваться, чтобы применять эту технологию для целого роя дронов.
То есть нам нужна некоторая коллаборация с COEX, чтобы узнать больше, как сделать систему управления роем, и все, собственно.
А какая коллаборация там? Как мы можем вам помочь?
Да нет, в целом просто совместно какие-то работы, наверное, попробовать. В целом, нам просто нужно время, чтобы
Вас плохо слышно.
Нам в первую очередь, на самом деле, нужно время на разработку, и COEX в этом плане является больше ориентиром для взаимодействия, да, и разработки. Вот, поэтому мы сейчас как раз активно разрабатываемся. Вот, а так, какие-то, может быть, совместные проекты попробовать, то есть какие-то разработки попробовать спустить на нашем оборудовании, чтобы взаимодействовали бы с COEX. Наверное, как-то так.
Ну, понятно, я вам могу посоветовать, как бы мы открыты, во-первых, да, каким-то предложением, а во-вторых, я могу вам посоветовать в чате техподдержки нашем попытаться, как-то рассказать о своей системе и найти там первых пользователей, чтобы они попробовали поэкспериментировать с вашим решением и дали вам какой-то фидбэк, как бы, что нравится, что не нравится, какой функционал еще хотят.
То есть, да, мы, в принципе, планируем работать с образовательными организациями, потому что это будет довольно полезно, если, допустим, есть класс, есть учитель, и если он дает полетать кому-то на клевере, он может сразу, если что-то понять не так, также вот быстро посадить, не знаю, там, чтобы зависнуть, просто контролировать. То есть это очень удобно было бы делать с нашего сайта.
Но вот здесь я не могу все-таки согласиться, потому что удобнее это делать. У меня эхо. Значит, без модема, а просто подключив дрон к локальной сети и все, и получив даже, может быть, тот же самый интерфейс, как у вас, но который работал бы локально.
Ну да, наш сервер можно запустить локально тоже, и чтобы клевера подключались к локальному серверу, это тоже можно сделать. Просто наш исходный код нашего сервера открыт, и любой может его скачать и просто захостить у себя на сервере. И даже без модема подключаться, то есть это вообще с этим проблем нет.
А это тоже одной кнопкой работает? Ну, одной командой.
Ну, да, получается, нужно просто скачать наш код с GitHub и запустить главный скрипт, все, он заработает.
Угу. Ну, ладно.
Okay, thank you guys. So well done, great project, and good luck to continue to develop it. And we're ready for the next team.
Hello.
Yeah, hi.
Yeah, our next team is Atena Grupo SEMEAR.
Can you see the presentation?
Yes, we do.
So let's start. Hello, now I represent to you the Swarming Blocks project, the project of the Atena team. We expect that you watch our final video and read a little of our documentation. Who are we? First of all, we are Brazilians. Atena team is part of SEMEAR group. We currently have more than 100 members at the University of São Paulo. I am Guilherme.
I'm Felipe. I'm José Carlos.
And we are the Atena team, composed by 6 members and 4 collaborators.
Now talking specifically about our project, swarming blocks. We know that one Clover is powerful and has many applications, such as the features shown on the screen, and it can be used to solve real-world problems. But is only one enough? Like, there are a lot of applications that require the use of several Clovers on a swarm. So why did we choose swarms? Well, swarms have a great power in collaborative work and also a huge commercial application in monitoring, agriculture, drone shows and transportations, and much more. However, manipulating a swarm isn't easy at all, requiring a deep understanding on control tools and programming skills. So we had to face this challenge. Is it possible to make a swarm of Clovers? Well, the original Clover repository was entirely built to work with only one vehicle in a simulation. So we had to adapt our workspace in order to run a functional simulation with several Clovers. With that in mind, we had to plan what we would do to implement a system that would allow us to put several Clovers in one simulation. But how will we make this considering PX4 backbone and the already built cross network for the Clover workspace? And that was the beginning of our project, Swarming Blocks. Here are some great results we achieved. The first one is the cube formation, which just distributes the Clovers in a 3D cube. And you can also see that it is possible to apply geometric transformations on a swarm. And with those tools, we were able to simulate and manipulate a Clover swarm on Gazebo. And in other words, Swarming Blocks is a framework with tools for swarm manipulation, focusing on usability. Now let's discuss more about our system, the swarming block system. The first part of what we would like to show you is exactly the front door of our platform, the front change. The main idea was to make the first contact with our project more intuitive and easy, trying to improve the user experience by simplifying access to packages, centralizing project information in the package list, and supporting the use of swarming blocks in general. Now, talking specifically about the block program interface, in general, we only improved the original Blockly available in the Clover blocks package, adapting the existing tools to our needs. But what have we improved from pure Blockly? At first, we added ready-to-use built-in blocks, mainly for swarm manipulation. Then, we've made some corrections to the display of on-screen tools, such as the simulation control buttons. In addition, we also implemented a dark mode option for late-night bug fixes that we all love. And finally, the addition of the launch button. So we realized that launching the swarm in the simulation was unnecessarily complex. So we built a launch button that generates a copy and paste command that can be used directly in the terminal. At this point, we'd like to present some comparison between the pure Blockly from Clover blocks and our swarm Clover blocks with the dark mode. Now on the screen, there is a demo of our interface. It's uploading the video. Okay, so starting with the localhost package list, running directly to the Swarm Clover blocks platform, and now is using the launch button. After the command generated is used to launch the gazebo simulation with the swarm, as in the screen. With all of this, we can use the Blockly API, making a program and running with the run button. You can get more details on all of these with other examples in our documentation.
So let's understand more how our system works behind. Swarming Blocks is a framework that we developed with several tools to control a Clover swarm. We developed the connectivity of all the drones with one node checking the ROS network for new Clovers. Also, one of our main tools is the automatic formation generation, with algorithms that generate circles, cubes, frays, meshes, and more. The other important tool is the generation of LED effects, with synchronized blinking and color changing. After that, we can visualize the final configuration of the swarm on a 3D plot provided by the Swarm Preview UI that we made. And then we can apply a synchronized movement to all the Clovers. We divide these tools in the Swarm control architecture in 3 modes. In the planning mode, you can generate and visualize the formation of swarms. In the simulation mode, you can simulate all the dynamics with excellent fidelity to the railroad in simulated environments. Finally, we can use the navigation mode after using these two modes, applying one real swarm of clovers in the railroad. As clovers use the software in the loop philosophy, the same code used in the simulation can be applied to the navigation mode in a real environment, and this process optimizes the development time. And all these features can be used with the block API, as you already know. Also, we can program blocks on mobile, run the code made by the cell phone on the PC that's simulating the swarm. Another way to use the swarming blocks is the Python API. Using swarming blocks with Python API is more customizable, and we try to bring the same facility and easy with a simple syntax. As an extension, we develop a UI to facilitate camera visualization and vehicle controlling. So we build the swarm first-person view, which is a real-time control with the keyboard for each drone selected based on their IDs. It's an intuitive UI made for immersive experience, and it's completely integrated with our project.
And now to conclude our project, we know that it's important to mention that there's a lot of room for improvement in our project. And the main thing is to work for an efficient collision avoidance system that we're looking forward to implement to make swarming blocks more secure and cleaner. And another point related to the previous one is the Real Clover Swarm application with physical drones. Unfortunately, our group cannot afford a swarm of real clovers, but we hope to do a system validation with our entire project on real clovers in the future. We are Atena Team, creator of the Swarming Blocks platform, and we thank you all for the attention.
Thank you very much. Very awesome presentation and project. Yeah, very well done. You're great. Thank you. So, okay, Oleg, your question first.
Yeah, I have, thank you for the presentation. I have several questions. The first, I more or less understand how it would work if you have one machine that runs simulations with multiple drones. But in real world, there would be multiple drones and multiple machines. So which of the drones will serve the interface of blocks, and how would this drone pass the trajectory to others drones? So I mean, would it even work in real life, or now it's only for the simulator?
Okay. You're hearing me? Are you hearing me? Okay.
Yeah.
So swarms today works mostly with the base controlling all the swarm and make it possible to connect each drones and manipulate each one separately. But in our project, we have one base control. The base control can run on the PC that is running on the ground station or on one Clover as its own ROS network. But it's necessary that all the Clovers on they have to be inside the ROS network, and then we can manipulate a swarm, control swarm with one base control that we have more processing power and other benefits like the UI. You can use the swarm preview UI. You can use the swarm first person view also, but we can also take the swarming blocks to one Clover, one chief Clover, one master Clover to control all the drones. It's possible too.
So actually, this one master Clover will execute the program from Blockly, yeah? But it will send commands in real time to other drones.
Yeah, it uses the service of each Clover. So it will tell each Clover that each one have to go to each position. And it not one thing that's processing much power. The simulation process much power, but in our code, the swarm blocks code is the timing of each response of the Clovers will affect more than the processing power taken into real time. So the Clover platform help us a lot in this case.
So you say that your work now is ready to run on real Swarm without any modifications?
Yes, we work thinking forward for the navigation mode. We have the navigation.launch scripts, and there is a ROS configuration that we would make to make it possible, but all the entire code is like to run. Yes.
And another question, what do you consider your software module? Should it be an extension to Clover platform? I mean, it's like a separate package, or you see it as a patch to the existing blocks, Clover blocks package? What do you think of it?
I think it can be merged and it can be part of Clover package, entire Clover package. It would be possible to, when you running with several Clovers, you can use the swarming blocks project that all we made to control it more easier, and we like it because there are a lot of things that we can make, apply, and develop more on top of swarming blocks.
Okay, because I will examine more deeply your pull request. I haven't done it already, and I think that we should discuss another option when we can separate this project as an extension to existing Clover blocks package, and we can think how to make it possible to add blocks to our implementation of Blockly with a separate package. Maybe it would be better option because not a lot of users have swarm of drones. So it's not so obvious if it should be a part of Clover, but maybe it will be possible to come up with option how your project can extend and be installed on top of existing Clover image. Okay, thank you.
Thanks.
Hello, thank you for your presentation. It was really cool. And as Oleg says, there is a lot of drones in Swarm, and they all should know their trajectory. And how you want to synchronize real drones? What you want to use?
We use the swarming blocks code that make the connectivity of our drones. It uses threads to each drone to call each drone service. So we use navigate, we take the navigate way, also get telemetry and more. So we instantiate each thread, and then we start then almost instantaneously. So it make the perception of synchronized movement.
Oh, you want to use something like timestamps to all drones? Yeah.
What? Sorry, I didn't understand.
You want to use something like timestamp and synchronize it, and then each drone will make their own program.
Yes, I think yes. I don't think I understand it as well.
No. I think their idea is that one of the drones would be the master drone who will control others. So the program created in Blockly just gets uploaded to the master drone, and the master drone executes this program and controls all the other programs, all the other drones. So there's no need to any synchronization, as I understand.
Yeah. There is one central code that calls all the service.
Yeah, thank you. That's what my question. Yes, because it's was very interesting. You want to synchronize each drone for other, or you have one drone? Thank you.
Yeah, I have a question. If you have a master drone, then if this drone fails, and drones do fail and fall, yes, regularly, then all other drones won't know what to do, yes?
We didn't make one script to return to home if the swarm master node fails, but it would be implemented. It will solve part of this problem. But if the ground control or the master drone fails, all the drones stays on their position because of the Clover services. Each drone set the target for its position, so they stay on there, and then we need to take another way to control them back. But yes, there is a point of failure that is the base control, and it is fail, all the drones stay without control.
Yeah, thanks. So it would be, I believe, far more logical to just not let the master drone fly, or to continue the thought just to use some kind of ground control station as master drone. Because if you let this drone fly, then you have quite high risk of failure of the event, because all the drones will freeze, and then you will have to do something, because drones, it's not uncommon thing for drone to fail for some way.
Yes. As I said before, if we are manipulating a swarm and we have a ground control taking this node of the swarm master, then our point of failure is on the ground, and it's more controllable, and it will be one more safe environment. We can use our computer as a swarm master.
Okay, thank you. And Oleg Kalachov has a question.
Yeah, I have one remark. We have several labs in here. I mean, in Russia, that runs swarms with Clover, and Oleg Panfilenik know, I think, them. So I believe we should connect this team and these labs to make the labs test their software. I think it would be very interesting. Will it work? So I ask someone to connect them, maybe Oleg Panfilenik. And
and also I'm testing your virtual machine right now, and it works, but I hate this virtual machine because it's very slow. So maybe you should also connect it with team second team. It's FTL team. Maybe they can add also your functionality in this virtual machine, because the virtual machine works much more nicely. But also I would like to ask people who are working with swarms to test your software too. And you also please promote your solution in our group, in our support group, and I think some Clover users also will try it.
And another question, I looked to your pull request when with the code, yes, and I actually don't see here any changes to the JavaScript file that contains blocks implementations. I mean, I don't see here any swarm-related block addition. Is it kind of a mistake, or I don't understand something?
All the code made for Swarm is in another repository for organization and it's on Swarming Blocks repository. So we made the package Swarm Clover blocks that has the .js files and all the code based on the Clover blocks. So much of their files are based on the Clover blocks.
So your pull request is only about some changes that you need to run your project. Yes.
Yes. For Swarm works on Gazebo and all the architecture works.
Okay. Thank you.
Thank you. And our final team is CopterCat.
Okay, thank you guys. Your project very great. Yeah. Appreciate it.
Hello, everyone. My name is Matvey, and today I will tell you what we're doing about half a year and what we will do in future with our project CopterCat. In the updates, we talk about all technical solutions. In the article, we talk about our features and how you can use it. And now I tell you about pros, cons, and how we will solve it. At first, we need to understand what we want to see as a result. We took a project from company case. It was building flying controller with FMU V6U standard, Raspberry Pi mount, and same size. Following the advice from first update, we adding flashing eMMC from a board, flashing eMMC on Raspberry Pi from a board, and adding built-in free-use microcontroller with Wi-Fi to make applications with mesh networking. And last but not least is child safety. We didn't want to protect child. We want to protect board from children. Let's start with most important part of the board for users, connectors. We take full set from Fixed Racer and add some extra. Now we have 8 ESC outs and 1 extra UART. For programmers, we add 2 camera inputs. One of them are high speed for line SSI, and over the board have USB that used how for setting all devices on board and to connect extra devices like stereo camera. And few parts from ESP32 GPIO to add extra devices like magnets and something. Why we choose ESP32 is the very powerful and very cheap microcontroller with built-in Wi-Fi transceiver. To maximize its potential, we install a lot of extra memory, flash, and RAM, and onboard antenna, Wi-Fi antenna. Also, this microcontroller support Arduino framework, and we promote mesh networking. And this solution is best because cheap, have Wi-Fi, open source, and a lot of RAM in external model. In future, when we order the first prototype, we can send you a video that where it's work very cool and useful. For developers, very important to know how devices on board are communicated. Here you can see two diagrams. First of them, when USB Type-C on board work in slave mode, when you can plug in into your PC and set up Raspberry Pi in OTG mode, PX4 and ESP32 for flashing or something. The second one is second mode that can work our board when master of USB on board is RPI, when all devices connected via USB to RPI from USB hub. And for USB Type-C, you can plug in extra device. At first stage, we want to use Raspberry Pi PX PCI Express port, but the solutions for convert PCI Express to USB 3.0 is very expensive and not justified. Due to the situation of components, we can't order the prototype, and at first stage of developing, we understand this, and for test something of some system on board, we simplify board, we maximum simplify the board. For example, in PixHawk 2.4, uses the same power system, and there uses the microchip, that expensive and hard to find, and we replace it with EDL diodes that built on one MOSFET and two transistors. Also, how you can here our board have OTG USB, and that means that we need delivery mode on USB Type-C. Also, chips for this are not exist because and we make a bipolar logical switching diode. It's the second picture, and all board characteristics are adapted for for manufacturing PCBs in Moscow, like in company Resonate. As a result, due to an error at stage of choosing standard, that was FMU V6U, we couldn't present prototype. But we're not upset because all systems are testing in local. We have complete PCB model with all tracks and with all tracks. So we need a couple of mounts to replace microcontroller and a sensors array. That we will do in few next month. And at the end of CopterHack competition, we understand that standard FMU V6U are die before it burn. And here is a solution to solve this problem. It's a table of existing standards. We understand that supporting own is very hard, and if we have complete, we need to use it. The first, it's a current, it's a die, we will not use them. The second and third is more interesting because on the market we can buy hardware realization of these standards and test. All of three STMs 32R7 are same with small difference. Like first in current version, the STM32 have TFT out, TFT display out, and we don't know for what. The second is not bad, but the built-in flash is very small, only 100 kilobytes. 16 megabytes is external modem. And the best solution is Matek, because big flash built-in size. With a microcontroller, we can order on Mouser or on AliExpress, and this is standard. You can download from ground control. The last is for a joke. We don't use Navia because it's bad realization. Here you can see all links for markets and documentation. In the future, in next 3-4 months, we will remake the board for Matek standard to replace sensors and try to order it in Moscow. And after testing hardware with existing standard, we want to write on with supporting network mesh network from flying controller to ESP without Raspberry Pi. And thank you for attention. I listen to your question. Here is the GitHub of product.
Thank you very much. Yeah, thank you. Good project. So, and I little misunderstand. So this Matek.
Мне говорят, я не слышу. Мне говорят, я не слышу.
Do you hear me?
Да.
Hello, hello. Hear me? Okay. Can you hear me now?
Да. Yes. Да.
Okay. Okay. Yeah. Thank you. Thank you for the presentation. It's great, and for the project. Regarding Matek H743 Slim, I opened the link, and on the website they tell me that I can install only ArduPilot and Betaflight, but cannot use PX4 software on this Matek. Why?
Yes, on official site Matek didn't exist. I don't know why. But if you open the PX4 firmware in boards, subdir Matek, you can see this configuration. It exists
and have you tried to do it, to run PX4 firmware on this board?
Yes, we won't order this board in one board and try to run, but we don't do it now.
Okay, okay, I see. Okay, okay. Share results, please, because it's interesting. Okay, Oleg Kochev. Oleg Kochev, your question, please. Okay, and Andrei.
Yeah, thank you. Do you hear me? Because it's. Do you hear me now?
Yeah, yeah, we do.
So, as I understand, you wasn't able to make your project in real life, yeah. But how can you actually validate and make sure that it actually will work? Because when you do some electrical device, it's very easy to make a lot of mistakes. So this thing won't just work or have some critical issues. So how do you validate that your device will actually work?
We tried on laboratories in university on LTH with our teacher. We show him our schemes. He say that this is not bad, and when we try it with some when we try it in real life in scheme locally. We don't make their own. We tested every system locally, отдельно. Separately.
So you kind of recreated everything on table from components.
Yes, yes.
And it worked.
Большинство.
Maybe some other validations from tools that you use, some simulations or something like this.
No simulations we didn't use. At first, my friend recommended me use Altium, but I don't like Windows, and I download KiCad, and in KiCad I can't run the simulation, and I now searching the solution of this issue.
Okay, because for example, one issue that we had with our SEMEAR experiment device was that it became very hot very soon after turning on. So it's one of issues with such devices that can happen.
The hotting is can be from over voltage or bug in manufacturing PCB. If you don't care about things with things of проводников,
conductors, yes.
Да, yes. Не, проводников. Built-in into PCB wires.
So you're sure that your schematic will work ideally?
I'm not sure for 100%, but it only first iteration, and it is we make 1 second. We make many tests in KiCad, like DRC tests, and read a lot of literature, a lot of books about this.
Okay, I hope that you will have a chance to actually assemble your device and test it. Thank you.
We want to rebuild our board on the Matec standard, and after we will order the board not in China, but in Moscow from Russia, because the price are not so big, not so expensive.
Hi, not so high. Okay, any other questions? Jury? Does anyone have some questions? Okay, thank you very much. Thank you for the presentation, project, and answering. And I think now we're ready to make final decision, right?
Let's continue. It's time to summarize results of our competition. Олег, could you please tell us?
Yeah, sure. Yeah. Thank you very much for everyone, for every participating team, you're great. You have made great work and achieved great results. And your project very powerful, very advanced, and we really glad to see it today. Okay, and places. We will publish a final table with all places and all scores for each criteria for every team. But now I will announce the winners. Starting from the end of table, the 8th place is going to DJS Phoenix Team. Thank you, DJS Phoenix Team from India. Thank you very much. You have taken 8th place. And of course, we invite all of you to the next CopterHack 2023. It's okay to participate with same project or with another project, up to you. But we invite all of you, of course. The 7th place is going to Stereo Team. Stereo Team from Russia. Great job. The 6th place is going to CopterCat. CopterCat. You took the 6th place, but you win in a special corporate category, the corporate case. It means that you get prize, special prize from company, but I separate this prize to 2 parts, and now I give you the second part, the first half of this prize. It's $1,250. You get it now, and the second part, the second half, second $1,250, you will get when your PCB board will be ready and when you test it to me for testing. After that, I will pay you the second part. But congratulations with winning in this category, and your project very important, and I hope will be very useful for Clover platform. The 5th place and $500 prize going to Space Clones. Space Clones. Sorry. Space Clones. Congratulations, you took 5th place in our contest. Great job. Well done. The 4th place is going to C305 Team, and also the price is $500. Yeah, congratulations. Your project very also very interesting, and I hope you will continue to develop it. And I hope some part of your work, what have you done, especially this part for using LiDAR and sensors, will be useful to other projects and future to other teams, and some users of Clover will use it. So I think your work is very important. So thank you again. Okay, and the 3 of winners, the 3rd place is going to Clover Rescue Team. The price is $1,000. Yeah, you're great. Okay, and the 2nd place and $2,000 is going to FTL Team. Well done. Great. And the winner of CopterHack 2022 is Atena. Atena from Brazil. You're getting first place and $3,000 prize. Yeah. Well done. Well done. And I hope to continue work with you in future to see how you will develop your projects, add it to Clover, and get your own users, testers, and maybe do next projects in future and participate in our next CopterHacks. So you are very welcome to participate in CopterHack 2023. Okay, thank you all.
Thanks for the competition. It was awesome. It was incredible.
You're welcome. So any other team, do you want to say something? Or jury, maybe some words from jury?
Yeah, I'd like to share some thoughts. You know, yes, we began to announce from the 8th place because all teams that made it to the final are, it's a great success, I believe. A lot of teams didn't make it, and it required enormous amount of work to just to get to finals. So I believe all these teams are very, very great, and their work is very interesting. So I thank very much all the teams that participated in our competitions. I think the projects were really great, and it was a tough call to decide who is the best. So thanks.
Thank you, Andrew. Alexei?
Okay, yeah, thank you all. It was really great competition. Thank you all the team, because the level of project was really very great. It was cool, and continue this work, making aerial robotics projects, because it's very fun, and good luck for you next years and all other competition.
Thank you, Alexei. Alexander?
I'm sad that our meeting is actually over, because I could listen for this stuff for hours more and never get tired of this. You guys are all amazing, and such a heartwarming meeting, and I miss all the guys that I know, and I wish that could be this to be continued. It was really hard to choose winners. And when I say that, I mean it, because the jury members' opinions were very different, and we had a lot of discussion in determining winners. So as I say, I could personally award like everyone with the equal prizes at the final, but I'm not in charge of that. So everyone has done a great work. Every team has their strengths and weaknesses. However, you guys are all amazing. So I'm working personally in raising UAS operators, not engineers or developers, and all of your engineering level is above and beyond of most UAS programs in the United States, and your achievements are a high chance to become acknowledged in developed countries as an outstanding or even extraordinary ability if you keep up the great work. So I greatly appreciate and admire your deep level of competences. With that said, please, in your future work, check up with the real world of people who are not familiar with drones and robotics at all, and focus on practical benefits and the problems you solve. And don't get tired talking about them. Don't get tired selling your product, because your product is amazing, but people still don't have an idea what drones are capable of and what is it all about. Yes, so more introduction, more practical introduction to your future presentations. and I'm sure that your product is deserves to be appreciated, and you should go ahead and sell it and make money. Thank you.
Thank you, Alexander, for these cheering words for everyone, every team. Yeah. Okay, yeah.
1 second. Yeah. I actually noticed that other members of the jury have already praised you, the participants. I'd love to say that this actually isn't a contest like it's just a CopterHack hackathon. So the thing which Alexei said, it's really great that you guys have done a very curious project which are actually helping other people to see the drone from the other perspective, and that's really cool. I do hope that you won't stop at this point. You've already reached the point way further than most of the UAS students all over the world, but there's still a lot to discover, and I sincerely hope that you will continue the development of your project. Some of them, as we just noticed, need to be polished, and we do hope to see you on the upcoming hackathons next year, or maybe in a few years, with some even greater projects. And it's really cool that this hackathon united people from all over the world. That's really great.
Thank you, Ilya. Jack, would you say something?
Yeah, sure. I just want to congratulate everyone, first of all, on great work that they've done. It was really impressive, and I'm really happy to have been involved. I was just very impressed with all the projects. I mean, just the entry level into starting to work with the Clover, there's so many things you need to learn and understand. Like, you guys are working with Ross already, and I mean, that's not a simple thing to work with for like university level students. So just congratulations and very well done.
Thank you, Jack. Thank you. Alek Kochov, would you say something?
I want to congratulate the winners. I want to congratulate all the finalists, because it's really, this year it wasn't easy to make it to the final, and actually we make it hard to do. So everyone who made it is a big achievement. I hope that we will continue this tradition on holding this event, and I invite everyone to our next events. I hope that they will be even more fun and even more cool. And if you have any questions or ideas, you can, all of you, you can write to us anytime, and you can write to me some questions or ideas on Clover platform, and I will answer everyone. So thank you for participating, and congratulations again.
Thank you, Alek. Yulia, would you say something?
Okay, my congratulations to everybody, to every team really, because you make really cool work in your projects, and I hope that all knowledge and that experience which you got during your projects will be very helpful and useful in your future projects, and I hope that you will improve your projects in the future, and we will see with you all again. Thank you for your job.
Okay, great. So thank you, teams, thank you, juries, and thank you, organizers, for this event. It was great. So see you next year. Okay, Yelena, your final words.
Yes, thank you so much, and you're the best. I hope I will see you soon. Thank you.
Guys, and let's say thanks to the organizers.
Thank you. Bye bye. Bye bye. Regarding your prizes, Yelena will write you in Telegram. It will be a direct transfer money from my account. So Yelena will write you about instructions. Okay. Thank you. Bye bye.